XML stands for Extensive Markup Language. It's a tool designed for transporting and storing data. That's the main purpose of XML. It's not used for output, or it's not used for fancy Outlook like CSS or JavaScript. It's not a programming language as well. It's just a simple markup language that allows us to store and transport data. And that's what we're going to learn: how we use XML and why we use XML. What are its basic features and what basic way of using XML with other languages like HTML and CSS has its role. Okay, so in this session we're going to talk about XML as a complete. We'll try to learn as much as we can using W3Schools website as a reference for our code. Now, a simple disclaimer: I'm not being paid, or as this is not an official W3Schools website. I just love this website and I use it for reference. So I'm using this so that you already have notes and you can go to this website and use this as a reference. And I'm going to explain to you all the basic concepts that this website has, so that it makes you and helps you understand a lot. My name is Dr. Zeeshan Bhatti. Before you go further, if you want to learn coding with me and if you want to explore more coding tutorials using W3Schools and other examples, don't forget to subscribe this channel. I'm going to post many tutorials on this channel as we go along. So let's begin this XML tutorial journey with me. Now, basically, as defined, XML stands for Extensive Markup Language, meaning that it's just a markup language. Its primary purpose is to store and transport the data. That's it. It does not represent the data. It does not give you an output. It does not show a very fancy way of representing the data. Nothing of that sort. It's just used to store the data in an organized, structured manner. That's it. So it's just like a backend programming language that allows you to understand and store the data in a very professional manner, which then can be used by other applications, other server applications, to understand what data you are using. So it's primarily just to maintain and design the data for both human as well as machine readable. So this is the key part here. It's like storing key information for machines to later on read and understand what exactly we are trying to do. So as an example, you would see that this is just a very simple node. Okay, we have a node to from the username, from another username, heading, what is supposed to be the heading, and body. Now these are tags. As we have done HTML, these are same as HTML tags, but the key difference is HTML tags are predefined. This is my own tags. I have defined in my own language and in my own understanding what these tags are going to be to store this information. If I check the code here, this is how the XML node is being saved. It will use these tags, and now again, these are not system defined tags, these are my tags. That's the beauty of XML. It's so open and so free to use that you can do whatever you want with it, as long as you follow certain norms and conditions. And that's what we're going to learn throughout this. So if I have this node, the machine is going to read it, and then we can use this node to define whatever data we want later on by any language we want. So you can use XML to decode using JavaScript, CSS, Python, PHP, whatever you want. Any machine programming language you want, you basically can use it to decode it. That's the beauty of XML for us. Okay, so here's another example for us. This is in a detailed XML node. Again, don't worry about right now. We're going to break this thing down step by step, and we're going to cover all these major topics. Will give you understanding. But what we're trying to do here is we are trying to define our own breakfast menu. So this is information for machines, in other words. Okay, and then this breakfast menu, I said, hey, listen, there's a food, and food tag ends. What is going to be my food? So I'm saying, okay, my food needs to have a name. So I created my own tag called name. Then this food needs to have something called price. So I define my own price. What this food is going to be about. So I gave a description. And how many calories this food is supposed to have, I have defined. So this becomes my own custom way of storing data in the system, which then can be read by the humans as easily as machines as well. Okay, so this is whole basic XML for us. Now let's begin and understand a little bit more in depth of an XML. So if you go next in next chapter, we said that XML is a software and hardware independent tool. That's the key thing that we're talking about. It's not dependent on the software. Means that it is not only that okay, if you're using XML, you need to use Python with it. Nah, you can use any language with that. You can use Java for it, you can use Python for it, you can use JavaScript, you can use HTML, whatever language you want, you can integrate XML with it. Whatever system you want, you can integrate XML with it. It's a completely independent tool based on software as well as on hardware. So it can be read and decoded on any single system that you are using. XML primarily stands for Extensible Markup Language. Okay, XML is a language much like HTML, but it's not same as HTML. There's a key difference. I'm going to talk more about that. XML was designed to store and transport data. We've talked about it. XML was designed to be self-descriptive. Now, here's the key, what we call the nugget that behind it. That's the whole XML's description in one line. It is designed to be self-descriptive, meaning that the language that will describe itself. That's why XML stands apart from every other language that we use. It's used to design so that you can easily read it yourself and understand what's happening as a human, and then you can define your machines that, okay, if you find this node, what are you supposed to do with that? If you find this tag, what are you supposed to do with that? So it's a whole customizable things. It is what we call W3 standard consortiums recommended. So it's recommended highly by W3 consortiums. So let's understand what XML can do more. So XML does not do anything. Again, this is what I think that you have to be very clear about. XML technically does not do anything. It's just there to store the data. Data that can be read by a human and machine at the same time. Okay, maybe it's a little hard to understand, but XML does not do anything. This node is a node to TOF from Jani stored as an XML. So if you take this is a simple node. It's from Jani and it's addressed to TO. It has a heading, it's a body. It's all these tags are what we call self-descriptive. These tags are defined by me. It's not being predefined. Okay, so the above XML is quite self-descriptive. It says that it has a sender information, it has a receiver information. So it has a sender information, it has a receiver information, and it has a heading and a message body. But still the XML above does not do anything. It does not do anything. XML is just information wrapped in tags. Okay, so that's the key thing that you need to understand whenever we are using XML. XML doesn't do anything. It's just the way of storing data. It is just the way of storing information wrapped inside specific tags. We use tags so that machine can understand it later on. Okay, then you can write code in any software that you are using to decode this and then understand what's happening. So you have two from reminder and the message. This is again done through any languages. Okay, now before we go again further, it says that let's understand the difference between XML and HTML. XML and HTML were designed with different goals. Okay, these both languages are quite different and they have a very different goals in their mind. XML was designed to carry the data, in other words, storing the data with focus on what data is. Okay, so with focus on what data is, whereas when we use HTML, it is designed to display the data. HTML structures the data, yes, but with display purpose as well. So how the structured data is displayed on the browser, that's the key thing. But with XML, we just use to store the information. That's it. With focus on how the data looks. So HTML has a focus on how the data looks. So that's why we have a heading tag, we have a paragraph tag, we have a bold tag, italic tag in HTML, we have table tags in HTML, we have links, images. All these things are representing how the data is supposed to look on your web browser. Whereas XML just focuses on storing the data, carrying the data. That's it. So XML tags are not predefined like HTML tags. So HTML tags are almost all of the tags are predefined. So paragraph tag, heading tag, bold tag, italic tag, div tag, table tag, underline, all these tags are predefined. We have to learn these tags, that what is the purpose of each tag and how we use them. Whereas in XML, we define our own tags. So that's hopefully a clear differentiation between these two things. In XML, we define our own tags, whereas in HTML, the tags are already defined and they serve a particular purpose of structuring and displaying the data on a browser. Whereas in XML, it's just for storing the data with our own tag names. Okay. XML does not use predefined tags. So that's already we talked about. So this is that HTML has many of the predefined tags, whereas XML, or the author, the one who is writing this XML, must define both the tags and the document structure themselves. That's why it is so extensively, freely, and powerfully available, because you are customizing your own XML. You do need to follow certain structure though. We'll talk about this as we go along. So XML is extensible. By what this means, that XML applications will work as expected even if the data is added or removed. Imagine an application designed to display the original version of Node XML to from heading body. Then imagine a newer version of Node XML with added date and hour elements, and they remove the heading. The way the XML is constructed, the older version of the application can still work. So even though we have an older version, it will still work. So we have the predefined data and we added the new data. The system will still work perfectly. We don't have to mind with that. So the older version does not have a date. The newer version will have a date. No problem with that. Okay. So XML, why again we need to use XML? Okay. Because XML simplifies things. XML will simplify things. XML simplifies data sharing. Once you write the code in this thing, now you can share this data across platforms, across languages, across tools. Any language can use it freely. XML simplifies the data transport. The data can easily be transported across multiple platforms through multiple programming languages. XML simplifies the platform changes. So even if you are changing the platforms from one app or operating system to another, doesn't really matter. XML will work perfectly on everybody. XML simplifies the data availability. Okay, these are the four major advantages or uses and purpose of using XML. Many computer systems do contain data in an incompatible formats. Okay, this usually come across when you have a Linux data format, you have a Windows data format, you have a Mac OS data format. But using XML ensures the data is read, understood across these platforms. Exchanging data between incompatible systems is a time-consuming task for web developers. Okay, so large amount of data must be converted, and incompatible data is then lost. XML stores data in a plain text format. That's the key thing, a text format in just simple plain file, which is again readable by across all platforms. XML also makes it easier to expand and upgrade new operating systems, new applications, or new browsers. It doesn't really matter. The data is not lost. The more you upgrade the latest core, you can still read a data of XML 10-year-old. Okay, it doesn't matter. The system will read it. With XML, data can be available with all kinds of reading machines like people, computer, voice, news feeds, etc. So that's the key thing with XML. So once you write an XML, it can be read by humans because we can understand what's happening here. And then it can be read by machines, computers, voice machines, news feeds, any system that you want to do that, it's available. And most importantly, it is what we call W3 Consortium's recommended system. Okay. So this is all introduction of XML, why we need XML and how XML is important. Okay, so I hope you understand up till this point. Now, how do we use this XML? Let's go on to the next chapter. So now in this chapter, let's discuss how can XML be used. XML is used in many aspects of web development. Most primarily, yes, we do focus on XML with respect to web development. XML is often used to separate data from a presentation. So presentation like CSS allows us to present the data. Okay, but XML primarily is used just to store the data. So it separates two things very clearly. It sets the boundaries very clearly. XML separates data from presentation. XML does not carry any information about how to display the data. That's the key thing. Do remember that. When we talk about HTML, HTML has that information. When we use heading 1 tag, we're telling the browser the heading is supposed to be 1. When we're using a paragraph, we're telling the browser how the paragraph should be displayed. We use CSS to design that data. For XML, no such thing. It's just storing the information purely in a stored form. The same XML data can be used in many different presentation scenarios. Because of this, with XML, there is a full separation between data and presentation. So there's a full, clear separation, distinction between how data is stored and how data is to be represented. We primarily focus on how data is stored rather than worrying about the presentation of it. Okay, so XML is often complement to HTML. What do we mean by that? So we say that in many HTML applications, XML is used to store or transport data. So it complements the HTML. So we use XML to store the data or transport the data, while HTML is used to format and display the same data. We have been talking about this all along. So HTML is used to format. That's why heading tags, paragraph tags, bold, all these formatting and structuring tags are there, ensuring the data is displayed correctly on the browser. Whereas XML is just there to store and transport the data. XML separates the data from HTML. What do we mean by that? It means that when displaying the data in an HTML, you should not have to edit the HTML file when the data changes. With XML, the data can be stored in a separate XML files. With few lines of JavaScript code, you can read an XML file and update the data content on any HTML page. That's the key thing. So we separate the data from HTML. We save the data in a separate HTML, XML files, and then we use the JavaScript code, for example, to read the XML file and update the HTML web page contents. That's how it basically works. So let's see a very quick example of it. Now we again come to this bookstore example. Now this is a typical structure of how XML is written. First, we write the tag, the angle bracket starts, question mark XML. This marks an XML document. Then we provide certain metadata. Metadata means data about the data, which is version 1.0, encoding UTF-8, and then question mark ends. This first line indicates that this document is of XML type with version 1 using a UTF-8 encoding text scheme. Okay, then we start with our XML document. Now again, this is completely customized. Every XML document will have a different look to it. The only thing to look out for is the tags and the structure of the tags. That's it. The content of the tags would change dramatically. It's up to you how you define it, and that's how what we're going to learn. We just have to understand the structure. So first structure is we create a bookstore. So this means that this entire XML defines the data about a bookstore. So we have a main tag, it starts here and then it closes right at the bottom here. Okay, so this tag closes right at the bottom here. So we have an bookstore starting here and bookstore closing here. Then we define books. So this is book 1, this is book 2, this is book 3. So every book that we have, we define a separate book tag for it. So book 1 is my first book. Within this book, I have defined an attribute called category, that which category this book belongs to. There is a second book, this time this belongs to a children category. We have a third book that is a web category. We have a fourth book, this belongs to a web category, and it has a cover as well, which means that it also has a paperback cover. So you see, we are defining custom attributes and custom properties. These categories not defined. This is my own word that I've used. I can use any other word for that matter. As long as I know what the purpose of that word is, I can do whatever I want. Then within this book, I know every book needs to have something called a title. So we provided a title. Yeah, we provided a language as well. We don't need to do that. Again, if I want to omit it, I can completely omit it out. I have an author. Every book needs to have an author. So we start an author tag. We provide an author name and then we close the author tag. The starting tag again is marked with the angle brackets, the name of the tag, and then the closing tag. Then every tag this is basically everyday Italian, the content of this tag. Then the closing tag starts with the angle bracket / title, similar to HTML. So if you have been following that thing, we have done HTML in my course. The link is in the description, or you can find it on my channel, the complete HTML using W3Schools. We've talked about this tags and structure extensively in that. So let's move forward. Now we have year, price, and see this. So these are all XML structure. That's it. That's the whole basic gist of XML. You just have to understand that, okay, in order to define the data, I need to use something called tags. And I can put any tag, any name, anything I want, as long as it makes sense. So the title, because this is a title, I use a title tag. Makes sense, right? Then if this is the name of the author, that's why I use a name of author here. I can use a person, I can a human 1, human 2, whatever I want. But just to make things more interesting and understandable, we use the word author. This is my tag. Again, this is not defined. Year, again, because this is a year, I can use a date here. I can use the word date, no problem with that, because again, I'm using 2005. But with books, usually we use the terminology called year. So this is, in this manner, we have defined the content here. Now, because this web has multiple authors, so I have author, another author, another author, another author. Again, I can do that. So now I have structured my data, stored my data in an XML document. You will learn a lot more about using XML and JavaScript in the DOM section of this tutorial. So we will be discussing more about this thing in the later DOM section of this. So stick around to learn all about this XML. Okay, so now let's move forward to something called data, transaction data. Okay, so thousands of XML formats exist. Because it's so open, there are hundreds of different formats people have defined, and you need to understand basics of HTML, and you can understand and read all those formats in many different industries to describe day-to-day transactions. So from stocks to shares, financial transactions, medical data, mathematical data, scientific measurements, XML can be used everywhere. But we also need to understand that every system has its own specific way of representing their own personal data. So we just have to know and use that. So for example, if I'm using XML as a news, okay, so how do we create an XML for a news? Let's go. We say the XML news is a specification for exchanging news and other informations. Using standard makes it easier for both news producers and news consumers to produce, receive, and archive any kinds of news information across different hardware, softwares, and programming languages. So an example of an XML document could be that again, we provided the initial line. This is just a recommended, not 100% compulsory, but this tells our systems that this is an XML document. So we say angle bracket question mark XML version 1.0 encoding UTF-8 question mark and bracket close. This signifies that this is a pure XML version 1.0 document. Then NITF. This is my tag starting and then as closing. Okay, again my tag name, so it doesn't have to be anything. Then within this news tag I have a head tag. It's supposed to be a title, Columbia earthquake. Then I define a body. Okay, and then I created this body. So inside this body I say there's a headline, there is a b line, there is a data line, and then within this data line I provided more information about each tag that I want to provide. So this becomes a very simple HTML document. This does look similar to what we call HTML, but this is not, because HTML uses HTML tag. This is my own tag here. So example for a weather service, for example, here is another thing. So an XML notation for weather service from NOAA would look something like this. We can say, again, this basic XML code goes on every XML document. We can say current observation. What's the current observation of the weather? Hey, there's a credit, NOAA National Weather Service. So this is credit, means this particular news weather service belongs to this thing. The URL, credit URL is this one. The image that I'm going to use is an image tag, URL, title, link. Now, again, do mind, these are all my own custom names. Don't think that these are predefined tags, that you have to use the same names every single time. Nope. These are my defined names. When you create your own XML document for your own data, you just need to use tag names that make sense to you. That's the beauty of XML. So these are all custom names. It might look like, okay, URL could be a keyword, but it's not. But we use the word URL because we are using a URL and it makes much more sense. But I can say, hey, URL for my address, URL for my address works fine. Title of my page works fine. Link to the website, link to the website. So I can use those tag name as well. Works fine, should be fine. Okay. Then we have something called locations, stations, latitude, longitude, observation. All the information that this each data is representing, I put this inside the tags. Using this, now you can see this, it becomes much easier to read the data as a human as well. That this is the location. Okay, this is the location. I don't have to specify. I don't have to use a subheading or any other thing. This is my station, KJFK. This is my latitude. This is my longitude coordinate values. Wonderful. Similarly, I have all other information defined within the respective tags that I have created. So this becomes my simple XML document. This is how we use the XML. Okay, so I hope you understand up till this point. So don't worry about, again, this name. Keep this thing in mind. These names are my own defined. When you define your data, it's up to you how you define it. Okay, these tags becomes your tags that you define, and no matter how you define it, as long as you start the same tag and you close it with the same tag spelling, that's the only thing that we worry about. Okay, wonderful. So now let's move on to the further next section. The next section talks about the XML trees. So if I go next, let's start to learn this XML trees section. Okay, so this XML tree, what do we mean by XML tree? XML documents form a tree structure that starts at the root and then branches to its leaves. Okay, so if you understand a tree, or if you have done a little bit of programming or data structure, basically a tree structure follows in a very simple way, that we have a one main element as a root, and then it has multiple childs. Each element of a child has more elements as its subchilds, just like a tree and its branches. So we have one main root, and then the root branches out. Okay, so this is a tree structure that we call. So in this case, it's giving us an example. So we have a root element, for example, a bookstore. Then a bookstore needs to have child elements like books. But then this book also has an attribute associated with called category. Okay, so we have a category associated here. Then this book can also have elements like title. Book can have elements like author. Book can have elements like year. Book can have an element like price. Each of these price has values. Year has a value, and the author has a value, and then title has a value. They can be a siblings. They can be having an additional attributes, like a title has an additional attribute called language, and so on and so forth. So it represents a tree structure. Okay, so an XML document, the image above represents a books in an XML. So this is the image, and this is exactly what we talk about here. So you can see this, the main root is our bookstore. Now here, do keep in mind, this line is not the root element. Okay, this line is just the metadata telling our browsers or whoever system we are using that, hey, this is my XML document that I'm using. So this is a metadata. Okay, so this does not count as a part of your data. It's just an additional information. So the part of the data starts with the bookstore. So this bookstore becomes my main root element. Okay, then within this root element, I have book 1, I have book 2, I have book 3. So within this element, we say we have a book as a main child. Each book can have a category. That's why we come here. Each book can have an attribute called category. Each book has an attribute called category. Each book has an attribute called category. Then each book has sub elements as its children. Okay, so you can see this book has sub elements called title, author, year, and price. So we come here. So inside this book, okay, we have title, author, year, and price. They become its sub element. This is how the structure works. This is all you need to understand, how to write a structured XML document. You need to follow a tree structure, or sometimes we call it a hierarchical structure, or also we refer it to as a parent-child relation structure. So we have a parent. This parent has multiple children. Okay, so each children then is a parent, and it has its own sublinks or subchildren. Okay, so let's go. So book is like a parent to title, author, year, and price, and then bookstore becomes a parent to book. So parent-child relation or a hierarchical relation is there. This is how the tree structure works. So an XML tree structure in XML documents are formed as the elements of trees. Okay, so an XML document, all elements are basically considered as elements of trees. An XML tree starts at a root and branches from the root to a child element. So this is how basically it works. We have a root. We then inside the root we have a child, and then each child can have subchilds. So there's usually one root. Is to just follow the basic root of thing. There's always one root, and then within one root we can have multiple childs, and each child can have multiple subchilds. That's the basic structure of XML document. Okay, so that all elements can have sub elements of child elements. That's what we talk about. The term parent, child, and siblings are used to describe the relationship between the elements. Okay, so this is what we call, this is why we say parent child relationship. So we have siblings, subchild, we have a child, and then we have a parent. So there's usually one main root parent, and then one main root parent has multiple children, and within each child then we have multiple. Okay, so parents have children, children have parents, siblings are children on the same level, brothers, sisters, and XYZ. All elements can have text content. So all elements can have a text content. So each element can have its own separate text content. Understand? Wonderful. Moving on forward, we now say self-describing syntax. Now here's what we mean by self-describing syntax. Remember, we talked about this in introduction, that HTML is basically self-describing. Nothing is predefined. Only the structure. This structure is main thing. That's it. If you understand this parent-child relation is hierarchical structure or the tree structure, that's all that HTML there is to HTML. Okay. Then within this structure, we use this for this principle: element and attributes, element and attributes, element and attributes. Okay, and then each element will have the data, the value, okay, the text as we call it. So this is what it is talking about, that each element will have text content. Okay, so each element will have some text content. Element will have a text, element will have a text, simple as that. Self-describing syntax. Now what do we exactly mean by that? Let's learn more about it. XML uses much self-describing syntax. The prologue defines the XML version and the character encoding. Okay, so this prologue, this first statement defines the XML version. Okay, we say no problem, wonderful. We talked about this already. This is the first line, goes on all XML documents as the first line. But this is not actually the part of hierarchy. So do keep this thing in mind. This is not a root element. The next line is the root element of the document, which is the bookstore. The next line starts, and then we say there's a book element, which is the child. Okay, so this is a root element, this is a book child element. This child element has an attribute called cooking, or category, which is cooking. The book element have 4 child elements: title, author, year, and price. So this book element has a 4 sub-child elements: title, author, year, and a price. Okay, so this way we have book as a root, bookstore as a root, book as a child, and then underneath the child we have title, author, year, price. So root, child, and subchild relation. That's how we basically progress with this thing. Okay, so this is our basic tree structure within XML. If you understand this, all is clear. Let's move on to the next. Now let's talk about something called XML syntax rules. Okay, so what are XML syntax rules? We understood that in order to use XML, we have to use a tree. Okay, that's the first step. The second step is the basic syntax. The syntax rules of XMLs are very simple and basically logical. The rules are easy to learn and easy to use. So don't worry about that. This is not a very complex language like Python or Java where you have to go into very programmatical and structural and syntax rules. This is very simple. The XML document must have a root element. That's the first rule. Okay, we saw this in the tree structure that in order to begin, you must have something called a root element. It can be anything. The name does not matter. You can write ABC, blah, 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 hello, hi, how are you? Anything can be there as long as it's the first root element. And then root element is closed here at the bottom with the same name. So XML document must contain one root element that is parent of all other elements. That's the first rule. That's the one rule to rule them all. Okay. Then in this example, the note is the root element. So in this example, again, the note is the root element. Reiterating the previous thing, this is not a root element. This is just our metadata telling our system that we are using XML file. So do not count this as a root element. The root element here is the note. Okay, and then node root is closed. Everything inside it becomes the child element of this node. So the prologue is there. The line is called as XML prologue. So this line is technically known as the prologue. We will be referring to this as a prologue. This XML prologue is optional. If it exists, it must come first in the document. If you want to write it, it must be the first line in your document. It's an optional. You can omit it out, but it's always recommended. Really give it a no problem with that. XML documents can contain international characters like Norwegian or French and XYZ. That's why we need to provide some information here. To avoid errors, you should specify the encoding used or save your XML files as UTF-8. Okay, UTF-8 is the default character encoding for XML documents. So it's a default universal text format. UTF-8 stands for universal text format. It's a universal text format. It's standard. You use it and you must provide it so that your document does not contain any encoding errors. So character encoding can be further studied. If you follow this link, you can further study these character sets and encoding schemes. Okay, so use UTF-8 is a default for HTML5, CSS, JavaScript, PHP, and MySQL. So if you are coming into web development or coming from web development and or you're going into web development, do remember this pro tip that UTF-8 is also considered as the default encoding for all our programming tools, starting from HTML5, CSS, JavaScript, PHP, and MySQL. Okay, now let's talk more about the syntax. All XML elements must have a closing tag. That's a key thing. So in XML, it is illegal to omit the closing tag. All elements must have a closing tag. So the first rule was the root element. The second rule is that you must start a tag and then you must close it. Okay. In HTML, there are various tags that do not close. Okay. So like BR tag, like image tag, like HR tag, they have no closing tag. But XML tags must be closed. Okay, now again, do note that XML prologue does not have a closing tag. This is not an error. The prologue is not a part of XML document, as we have discussed previously as well. It is just a metadata. It is not a part of the document. It's not considered as an XML structure or data structure itself. Okay, so it's because it's not a part of document. It does not have the closing tag. So this does not have a closing tag. So don't worry about that. All other tags must have a closing tag. So we start a note, we close a note. We start a to tag, we must close the to tag. And the syntax is very simple. Use a backslash to within this angle brackets. From, close from. Heading, close heading. Body, close body. That's the whole gist of it. So you must have a root element. You must have child elements. Each child element has a data sets inside it. You must have what we call a starting tag and a closing tag. That's the basic rule that we follow here. XML tags are case sensitive. XML tags are case sensitive. The tag letter is different from the tag letter. Okay, meaning that this is capital L and this is small l. So these two are two different things. Unlike HTML, XML is case sensitive. HTML content is not case sensitive. So we can skip out that point. In HTML, we don't have to worry about case sensitive issues. But whenever we're using XML, do be very careful of this. Okay, so its syntax does require us to understand that, hey, listen, These two words, capital L and small l, are two different things. So XML will consider them as two different tags. So if you started with a capital L and close it with a small l, XML will not be able to understand it. It will not be happy. Opening and closing tags must be written in the same cases because obviously this is case sensitive. So you start with a small m, you must close it with a small m. If you start with a capital M in this case, you must end it with a capital M as well. So just do be very careful with that. Okay. Then the next rule that we need to follow with respect to XML syntax is that XML elements must be properly nested. The tree structure. That's the key aspect of it. Okay, so XML does require you to follow the tree structure properly, meaning the nesting of subtags, the parent and child relation, must be properly followed. Let me show you an example with HTML. In HTML, we can get away with an improper nesting. For example, if I create a bold tag first, then I write an italic tag. This is bold and italic, the text come here, but now I close the bold tag first. Because the bold tag started as a first, then there's a nested I, but at the ending this is bold comes first, so this is an invalid nesting. Okay, this is not correct. For HTML, doesn't really matter. HTML will display this perfectly, doesn't complain, no problem with that. However, when we talk about an XML, XML will say, nah, I don't like it, mate. So XML will complain. So for XML, the proper way of doing is that we start a B tag, we write an italic, then this is a text, a bold italic, the content goes here. Because the italic was inside, we close the italic tag first. Because the B tag came first, it will be closed as a last. This is a proper nesting example in XML. Again, if you look up here, in more appropriate examples, where we go here. So we start two first. This is a starting. So we close the two first here. Okay. If we start from tag, we close the from tag first. If you put this to tag after the from tag, XML document structure becomes invalid. So you need to be very, very mindful of that. Okay, so we say, this does not work. So this is what it's talking about, that you must use a properly nested text. Okay, then we say that XML attribute value must always be quoted. This is another rule, that XML elements can have attributes. So each element can have an attribute. Again, this attribute is your defined. You can give whatever name you want to this attribute, doesn't really matter, as long as you follow a proper structure, which is attribute name, equal sign, quotation start, and then the value within this quotation marks. So it says that every HTML attribute must have these quotation marks. So XML elements can have attributes, but you must use the name and value pair. So this is name is equals to its value. This is the syntax of using it. Okay, so we must use these quotation marks. That's another reference rule that we follow. Entity reference. How do we refer an entity? Some characters have special meaning in XML. Some characters do have a special meaning. If you place a character like angle inside an XML element, it will generate an error because the parser interprets it as the start of a new element. This will generate an XML error. So for example, if you use message as a tag, you start it, you give a salary, then you want to say my salary, your intention is to use this less than symbol. Okay, less than 1000, but because this symbol is specifically reserved by HTML and XML as a starting and ending of tags marker points, they will complain. They will think that you're starting a new tag here or trying to close a tag here, and then it says, hey, there's misconception here, then I have another starting tag backslash message. So what is the purpose here? So this will give us error, so it will get confused. What the hell are you trying to do here, right? So it's always recommended that please try to avoid such symbols. To avoid this error, replace this sign with entity reference. By entity reference means special characters. So we say use a special character such as and the right and alt semicolon. So this is now a symbol that is used to replace this sign, which is less than. So if you want to use a greater than sign, we use and, GT, and semicolon. This and is read by XML as a special symbol, allowing it to understand that I'm using a special characters. Okay, we call them special characters or escape characters in other languages like Java or C++ or Python. Okay, every language has these special characters. In HTML, in order to use these special symbols, you need to use these special codes. Okay, so these are like secret codes of using these things. Even and, because XML recognizes and as a starting of a special reference. So if you want to use an and in between here, you cannot use a direct ampersand. You need to use and, amp, word, and semicolon. This would indicate that I want to use this symbol. Similarly, apostrophe or a quotation mark, because quotation marks are considered as a pairing elements for our attributes. So if you use quotation marks, again it will complain. So every time you want to use these symbols, you would actually have to use these points. That's one key thing here. So only this bracket and are strictly illegal in XML, but it is good habit to replace these signs as well. So it basically means that only this less than sign and the ampersand sign, these two are strictly illegal. You can get away with these symbols, single apostrophe, double apostrophe, comma. You can get away with this, it can work sometimes. But still, it's a good habit to replace these symbols as well with these signs. Okay, so this is one more rule that we need to worry about. Finally, let's talk about comments. Now, comments are absolutely important. If you're a programmer, you have been doing programming for a long time, you would know that within XML, programming are key thing. Okay, comments are key thing. Sorry. So the syntax for writing a comment in XML is similar to that of HTML. So if you have done HTML, or if you are following from my courses on HTML that I've uploaded, you would find that we have talked about HTML comments. And the way we write HTML comments is we use this angle bracket, exclamation mark, minus minus, and this becomes a comment, minus minus, angle bracket. Comments are actually not read by at all. These are just comments. They have no meaning, no importance. They are not read, they are not printed, and no output is given. So this is like a note to self. Okay, so they are not part of the actual data. Do mindful of that. So comments basically mean that if the browsers, the systems, the every programming language will basically ignore whatever you have written in these symbols. Okay, so two dashes in the middle of the comment are not allowed. So if you write two dashes in the middle of the comment, this will again complain. So do very careful about that as well, because these two dashes signifies the part of the syntax for the comment as well. Okay, white spaces in preserved HTML. White space is preserved in XML. What this means is that XML does not truncate multiple white spaces. HTML truncates them, right? So if you write XML hello space 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 trove, XML will consider this as having multiple spaces. Whereas if you execute the same code in HTML, HTML will print this as trove, because HTML actually ignores such kind of multiple spaces. And if you need to add so many spaces, you have to use a special symbol at the rate 20%, percent 20 sign. But for XML, if you use multiple spaces in between, it will consider these multiple spaces as characters and will render this on your screen, depending on what language you are using. XML stores new line as LF. So if you want to use this new line, if your data within your XML has multiple lines inside it, the information within the tags have multiple lines, they will also be stored, and XML will use LF as a new line. Windows application stores a new line as a carriage return and a line field, CR plus LF. Unix and Mac OS uses LF, old Mac systems uses CR, and XML stores the line as LF. Okay, so do be mindful of that. Okay. Well-formed XML documents that conform to the syntax rules above are said to be a well-formed XML document. So now whenever we are working with XML, we are always expected to create a well-formed XML. It has these basic syntax rules. Let's revise them very quickly. So the first rule, XML must have a root element. Okay. The second, the XML prologue is not a part of the content. Okay. The third rule that we define, that XML tag must have a closing tag. Unlike HTML, XML must have a start and closing tag. Each tag is case sensitive in HTML. That's the third rule. Each tag in HTML is a case sensitive. So small l and capital L are two different tags. All XML tag must be properly nested. So if you have a B as a first, the B must be as the last. If you have I in the inner tag, I must be as the inner tag closing before the B tag. That's a proper nested tag structure. The fifth rule is that XML attribute values must be quoted. So if you are using attributes, it must be quoted with the name is equals to value pair. So we use a name and value pair. That's the fifth rule. We use references if you are going to use special symbols. Symbols like less than, greater than, and, apostrophe, comma. these are considered as special symbols and they have a special code. You cannot use them directly. Okay. The sixth rule is comments. To use the comment, we use the same as HTML, angle bracket, exclamation mark, minus minus, and then minus minus, exclamation mark, angle bracket. But keeping in mind that these minus minus cannot come in the middle of the content because this remarks the end of the tag as well. So similarly, white spaces are preserved in XML. So these 7 are key main rules that you need to remember whenever you want to do the syntax. Okay, so if you are up till here, congratulations, you have completed 5 lessons of XML, and hopefully you have understood basically how XML is working, what its structure is. Next, we're going to talk about XML elements. Okay guys, so now let's move on to the next section called XML Elements. Now in previous sessions we have been talking about the syntax, trees, and how XML is working. So moving on further, XML Elements, basically these are the content that we put inside the text. So XML document contains XML elements. What is an XML element? Let me define. So it says that XML element is everything from including the element start tag to including elements and tag. So everything that you write inside your starting tag to your ending tag is basically an XML element. Okay, so this the whole thing, price and end of the price, this is basically our element. An element can contain a text, an attribute, other elements, or mix of above. Okay, so anything can be here. So for example, when we talk about book is an element. So this book can contain attributes. This book can contain other elements inside them. Okay, and then the element has to have a closing tag. So this whole one thing becomes one big element. Inside each element we have another element called title. This becomes an element, this becomes the text inside this element, and then that element ends. So this isn't a single element. This element itself can contain other subchilds as well. Okay, so this is what element is. And in example above, title, author, year, price, all of these are basically elements. Okay, they all have text content because they contain text. So everything has a text content as well. Bookstore and book have element contents because they contain elements. Okay, so they have element content. So the bookstore has elements. Okay, the book, sorry, and the bookstore itself has what we call elements. So this bookstore does not have any text, but it does have elements as its child, as its content, other elements as we call them. Okay, similarly, a book does not have any text, or in this case doesn't contain any text, but it contains other elements, but these elements contain text. Okay, so this is what basically we're talking about. So an empty XML element, what if I don't provide any element here? So this is considered as an empty XML element. An empty element with no content is said to be an empty. In XML, you can indicate an empty element like this. So we can have an element starting and then element ending. There's no content in there, no text, no sub element or anything, no attribute. You can also use a so-called self-closing tag as well. If this is an empty element, you can to a certain extent use a self-closing tag. This is again something we now do in HTML5 as well. There are elements like br, hr, since they don't have any ending tag, we use an element and then we close it just like this. So this indicates that this is no there is no text, there is no content, this is just a single tag here. But again, remember the HTML syntax rules, we should have an ending tag. So we try to avoid this as much as we can to simplify many things, but this is again allowable in this case if there is no content inside this element. If there is a content or text or subchild, then it must contain a closing tag, but since it doesn't, you can just write this tag for this purpose as well. The two forms produce identical results in XML software, readers in parser and browsers. So all the XML readers, parsers, and browsers will have exactly the same output for these things. Empty elements can have attributes though. So do keep in mind that these empty elements can contain attributes. Okay. XML naming rules. So the elements must have the following naming rules. Now we said that any names we can use, right? Any names we can use. We can put any custom name because there is no predefined names. But then XML says, hey, hang on. Let's not get so carried away. There are certain rules though, what names you can use. So XML says that each element must have these following naming rules. So let's talk more seriously about that. So it says you name anything you want, but make sure these names are case sensitive. So do keep this thing in mind. We have talked about this in syntax as well. Element names must start with a letter or an underscore. So you cannot start a name with a number or a full stop or at the rate or dollar sign XYZ. Each element name must start with a letter or maximum underscore if you want to do that. So it's always recommended. We have always, every time we use a letter to start our naming notes. Elements names cannot start with a letter, XMLs or XML or XML, etc. So these words, for example, XML, capital XML or capital X and ML are not allowed because these are reserved words by XML itself. So you cannot use XML as a tag name itself, okay, as an element name. Elements names can contain letters, digits, hyphens, underscores, and periods. So you can use any of these symbols as long as they do not violate the second rule, which is that it must start with a letter. So you must start with a letter, but the second character can be digit, hyphen, underscore, or any other thing. So the first letter must be letter, but then you can use all of these legal characters. Element names cannot contain spaces, so it must not contain spaces as well. It must be one single word. Now, if you have been doing programming, these technical rules are used across programming whenever we want to use variable names or class names or function names. Every function name must start with a letter. Every function name can contain digits, hyphens, as long as it's not a first letter. Usually the function names are case sensitive. They may not contain certain keywords or reserved words for each programming language. They cannot contain spaces. So these naming rules are actually followed across the board. You know, if you are into programming, from HTML to CSS to JavaScript to Python, Java, C Sharp, or any programming language you take, basically the naming rules technically are almost the same. Okay. Obviously, the keywords and reserved words would be differ in many languages. In this case, it says XML only. But if you are using Java, the word, for example, class or public or if or else or for, these are reserved words. You cannot use them. Same goes for JavaScript as well. So here we go. Any name can be used, no words or reserved words except XML. So there are no words are reserved in XML except itself word XML. So in Java, in Python, there are many reserved words. In JavaScript, there are many reserved words. However, it says, listen, in XML, no reserved word. Okay, wonderful, capiche. Then we say best naming practice. What's the best naming practice that we do? Now, this is something that we have little bit touched about in introduction and previously, but since you are allowed to name whatever you want, and as long as you follow these basic rules, there are certain best practice that what you should be doing. So it says that create descriptive names like person, first name, last name. Make them descriptive so that you understand what is the purpose of this content. As a human as well as a machine can do that the same. Okay, create a short and simple names like book title, not like the title of the book. Okay, so this is also valid. There's no problem with that. There's not error, but it's the best practice. You know, as a professional programmer, as a professional developers, we tend to say just use book title, man. No need to write a whole sentence as your name, right? This is okay, this is valid, no problem, but unnecessary. I mean, this shows you that you are not a professional. This makes much more professional sense. Book title, clear. No need to write a whole sentence. Avoid the minus sign. Okay, and if you naming something first name, some softwares may think you want to subtract name from the first name. So this can create a confusion. So that's why underscore is always our go-to sign. The first name minus, this minus is allowed in XML though. Do keep this thing in mind. So as per XML, this is legit, but it says that when we read this XML using certain softwares, they might interpret this minus sign as a mathematical minus symbol and hence can render an invalid result. So as a best practice, again, as a good habit, as a good programmer, we try to ensure that our code is properly formally coded and can be read across board. So we try to use underscore as often as we can instead of a minus sign. Avoid using a full stop as well. If you are using naming something like first dot name, some softwares may think of a name as a property of an object. Now, this is again a common thing. Programming like JavaScript, they use a full stop as a property of an object. For codings like Python, like Java, they do understand full stop as a connection operator between an object and a class value. Okay, so this can create confusion in some applications as well. Again, as a best practice, we use underscore. Try to avoid minus, try to avoid full stop, try to avoid semicolon as well, double colon as well. Okay, so this colon are reserved for namespaces. We'll talk more about this later on, but this is again not preferably used. So try to avoid this as much as you can. Okay, so non-English letters like these E bar symbols, O bar symbols are preferably legal in XML, are perfectly legal in XML, but watch out for problems if your software doesn't support them. So you can use them, you can have no problem with that, but just be careful that some softwares might have a problem with that. Okay, so that's the best naming practice that we use. So naming conventions usually follow that we use a lowercase, uppercase, all upper letter uppercase, as first names, next name, same as simply goes. Make sure all are different and all have a different meaning. Okay. Similarly, XML elements are extensible. By this, we mean that XML elements can be extended to carry more information. Look at the following example. So, for example, we say that note to from body. Let's imagine that we created an application that extracted to, from, and body elements from the XML document to produce this output. So, extracted to and used to understand which to whom it's being sent. From means who is sending this application, and we send a body. It's okay. So we extracted this information from the document using application like Python, Java, JavaScript, or anything of that sort. Then we say, imagine the author of XML document added some extra information to it. So now, once we have extracted this information, all okay, all done, khalas. What happened next is that the original file got updated and some additional information was added, like a date, like a heading, which was not initially available in the first document. So what happens now? What should this message be reflecting? Okay, so should the application break or crash? No, the application should still be able to find the to, the from, the body elements in the XML document and produce exactly same output. There will be no change in the output. The document would still work fine even though we have changed the XML file, because the original code would still look for the to statement, the from tag, and the body tag. It will use these three to produce the same output. It will ignore all these tags because the coding currently does not read this. It has been added on later after the certain code has been done. So this is the beauty of XML. This is what we say, that it is what we call extensible. Okay, or in the words of John Rambo, expandable. Okay, you can expand it and it doesn't really matter. The code would still work fine for us. Okay, so this is the basic of elements that we need to understand when we talk about HTML. Keep in mind these rules. Next, we move on to something called XML attributes. So if we go next, now let's talk about the attributes. We talked about the elements, we have talked about the syntax, we know that, okay, what are these elements and how to use them. Now let's talk more about these additional attributes. Okay, we have briefly talked about them in previous sessions as well. So these XML attributes can, or in other words, each XML elements can have attributes just like in HTML. So if you are following from HTML, you would know that HTML has attributes, so they can XML. Attributes are designed to contain data related to a specific element. So the primary purpose of these are that when we use data as an element, we need some extra information. We have a person. So, which person is it, male, female? Is it a gender specific or age specific or quality or category, or whatever ethnicity we want to define? So some additional information we need about that person. So that information is usually saved in form of attribute. Attribute values must be quoted. Either single or double quotes can be used. For a good person, for a person's gender, the person element can be written like this. So for example, we have a person element. The attribute can be written like this. Now keeping in mind this is a value pair. Okay, so we have a attribute is equals to and its value. Okay, this is a pair. It must be written in this format. That's one of the syntax rules of HTML, for XML. Okay, so we provided it gender is equals to and its value, or we can use a single quotation marks for that matter as well. Again, both are acceptable. So in double quotes or single quotes should work fine. If the attribute value itself contains double quotations, you can use a single quote like this. So for example, if your value contains a double quotation marks, so you can use a single quotation outwards, outside, and then use the double quotations inside. So XML will consider this as a whole one single statement with this word under double quotation marks. Should be fine, no problem with that. Or you can do use this dollar code sign that we discussed in the namespaces rule in previous sections. Okay, XML elements versus the attributes. Okay, so how do we differentiate and understand the difference between the elements and the attributes? Let's look at these two examples. We can use the gender as an attribute, as an element as well. We can say a person, gender is equals to female. Here we have defined this as an attribute of a person. And then we say first name, last name, and all other properties that can follow. Or we can redefine this as this way. So we can have a person as an entity, as an element. Then gender can be as a sub element of this person. Okay, so now we know this person has a gender and it has a female. At the same time, it has a first name, it has a last name. So in the first example, the gender is an attribute. In the last example, the gender is an element. Both examples provide the same information. So since it's so extendable, it's up to you how you best use your systems. Some developers prefer everything in form of attributes, in form of elements. Some prefer that you do provide additional attributes. It depends on what attributes you are using. Actually, that also matters. So in my case, I can use gender as a separate element as well. It allows me to understand more attribute more professionally, that this person has a specific gender, so that a person can have a gender female, male, or any other if that is a preference. Similarly, it can have an attribute as well. So it doesn't really matter, but depending on how basically we are working with that. Okay, so my favorite way is that following three XML documents contain exactly same information. The date attributes used in the first example. So in the first example, we have a note. The date is used as an attribute. In the second example, we have a date as an element. Okay, same thing. And in the third, we expand the date element is used in the third example. So we expand the date element, okay, which basically becomes more appropriate with. That's why we say I try to prefer, if this information is more specific and has a meaning to it, we try to use it as an element, because then later on we can extend it. Okay, because XML is expandable, remember that. So we can easily expand it later on and create a more meaningful way for it. So we can say, hey, note, date, we provide an element, and then we can provide a child elements more specifically. Year, month, day as a separate elements within the main child. This becomes more preferable. Avoid XML attributes. So some people do say that we need to avoid, and some things to consider when using attributes specifically. What we should do and what we should not do with these attributes. So for example, the attributes cannot contain multiple values. Elements can, right? So for example, a note, a day, a month, a year, this is a terrible example of using your attributes. Okay, then even to, from, headings and blah blah things, this is a terrible thing. Don't end up like this. Don't do this. This becomes a terrible way. We can write it, but this is a terrible way of doing an XML document. So attributes cannot contain tree structure. So these attributes cannot contain tree structure. This is just an attribute is single value. Attribute is a single value. These are all separate different attributes. If you want to use an attribute that contains element that contains multiple values and recognize each value separately with its specific nomenclature, then you need to use elements. That's why we say be very careful of what you put in attributes. Attributes are not easily expandable, so cannot be expandable. Okay, are not easily expandable. So if you have a system that reads a particular format, then you have to stick to it. So now if you want to change it and add more things to it, for example, you want now say, I don't need these three, let me just add one attribute, and I want to work with it. This is not so easily expandable, and the system can crash if the reading of that. So XML attributes for metadata. Okay, so what attributes we can use, or what's the best scenario for using the attributes? It is said that use attributes for a metadata, providing data about the data, if that is more understandable. Rather than providing the actual data in your attributes, try to use attributes as a metadata. So date here is an at data. Okay, so we it's not recommended to put it as a attribute. Similarly, gender is considered as a data. So don't put this as an attribute, put this as a tag, it's more understandable. But in what cases should we use? We use something like IDs, which are references are assigned to elements. These IDs can be used to identify XML elements in much the same way as ID attributes in HTML. Okay, so the example demonstrates this. So the example says that, hey, I can have two notes, note 1 or note 2, book 1, book 2, and I can use an ID attribute. Using this ID, I can individually identify each of these nodes. Okay, this ID is same as ID in HTML. So in HTML, we use ID attribute and we use JavaScript to process ID elements based on IDs. Okay, similarly, we can do the same thing in XML. So if you have been doing HTML course, or if you're following my JavaScript course, you will know this much better. We have talked about this ID a lot in HTML and JavaScript. So this ID is being used by JavaScript to identify each single element. in your HTML document. And similarly, JavaScript can be used to identify the same individual items from your XML as well. Okay, I hope that makes sense. So this is like a metadata. It does not provide the actual data, but just an ID, just a reference to this node, just an ID in the node. So this now makes sense to use this as an attribute rather than actual data, because this is not concerned with the data. This is just concerned with identifying the number, more like a serial number or page number, right? So this is where we put the attributes in. So the ID attribute above are identifying the different nodes. It is not part of the node itself. It's just going to identify it. It's not part of the data. What I'm trying to say here is that metadata, data about the data, should be stored as an attributes. So whenever we want to use metadata, which is basically providing additional data telling us what this data is about. So data about the data, as we call it, which is metadata. So whenever we're using certain terminologies that is supposed to be data about the data, we preferably use this metadata as an attribute rather than providing it as an element itself. Okay, so I hope that makes sense. So this is all about attributes. I hope you understand how we do use this, the nomenclature, the naming, and all the basic rules that are inside this. Okay, so moving on to this, next we're going to talk about the namespaces. Okay, now this is one of the most one of key sessions about XML. So namespaces, XML namespaces provide a method to avoid element name conflicts. Now this is one key thing. What if I use same tag names? What happens then? How do we identify each tag and what it's supposed to do? So namespaces are quite important, and it is used to avoid the name conflicts. What do we exactly mean by name conflicts? In XML, elements are defined by the developer. So all elements are defined by the developer. I'm defining it. It's up to me how I define it. This often results in conflict when trying to mix XML documents from different applications. This can create a conflict if you're using if multiple people are working on a project, they're creating different XML documents, and namespacing conflict can occur. So XML carries the HTML table form. Okay, so for example, we can say table tr tg table. This XML is basically in HTML table form. This XML carries information about a table, a piece of furniture. So now we have say that here's a table, name, Africa coffee table, width is this, length is this. So this is another XML. This is another XML. But the key thing to understand is they both use a table tag, namespace conflict. This is XML using HTML table. This is XML using my own information about the table. Okay, just my thing. However, because they both use table tag, there can be a conflict if you're using this with HTML, CSS, or JavaScript, because in that case, the browser might render this as an HTML table because the browser thinks this is an HTML table tag. This is what happens. So if these XML fragments were added together, there would be a name conflict. Both contains the table element, but the elements have a different content meaning. They both have a different contents and meanings. But because they both contain the table as a root element, there's a conflict. So a user or an XML application will not know how to handle these differences. How do we solve this? Okay, how do we ensure that if this is the case, this should not be a problem? So we use something called a prefix. Okay, we solve this problem or such problems by using something called a prefix. The name conflict in XML can easily be avoided using the prefix. XML carries information about HTML table and piece of furniture. So this XML has both things. We have combined both XML together. What we have done here is we have used something called a prefix. Okay, so H colon table, H colon tr, H colon td, and H colon. So we have added this H colon as a prefix before this table and F colon table before this table elements. In the above example, there will be no conflict because the two table elements have a different namespace. So now there's no problem. It's an extra workload, I know. It's a little confusing, I know. What we have done here is we have provided a prefix. In such cases where data is being merged or data conflict is occurring, the way to resolve it is by using a prefix. Prefix can be anything, as you would have understood, but these prefix indicate that you are using two tags that have two different purposes. One purpose is for HTML, for browsers to understand this, that this is an HTML like a tag and I have to display and render this in that manner. This is just an element tag for an XML having a certain information. We solved it by using this prefix. The rule of prefix though is make sure you use the same prefix across all of the per child elements and from the starting tag as well as the closing tag. Okay, so F colon is the prefix that we have specified here. XML namespaces and the XMLN's attributes. So now we introduce another attribute called XMLN's attribute. What is that? Let's talk about it now. So when using a prefixes in XML, namespaces for the prefix must be defined. Okay, so whenever we are using prefixes, the prefix a namespace must be properly defined. The namespace can be defined by XMLNS attribute in the start tag of an element. Okay, so we can define it using this XMLN predefined attribute. The namespace declaration has the following syntax: XMLNX colon prefix is equals to the URI. So for example, we can say that H colon table XMLNX belongs to this H is equals to www dot this particular URL. So this belongs to this prefix has this particular attribute associated with it. Similarly, XMLNS colon F is equals to this particular URL associated with it. So if the attribute has same thing, so we use XMLNS as a namespace prefix and we must need to define it. Okay, so in the above example, the XMLNS attribute in the first table gives the $H prefix a qualified namespace. So it basically says that in order to use this, we have to make sure that we define this namespace. What does $H colon H means? So we have given it a particular definition. Then only then can we use it. Here we have specified that, hey, I'm using a namespace called colon F and it points to a particular URL or has a different meaning to it, and then I'm going to use this $F here. So only then am I able to use and qualify as a namespace. XMLNS attribute in the second table gives the F colon prefix a qualified namespace. So this F colon, when we use it, because we have used it XMLNS colon F with a URL, now we have given it a particular definition. Because we have given it a definition, now we use it and it now qualifies as a namespace prefix. When namespace is defined for an element, all child elements with the same prefix are associated with the same namespace. So once we define this here, all child element need to have the same thing. Okay, namespace can also be declared in an XML root as well. So when we use this root prologue, we can define this XMLNS and a root element as well. So we define root XMLNS colon H and XMLNS colon F. So we have defined both these attributes in our root tag. And then we can use this blah 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 things here. So in our root tag we have defined, and then now I need to define here, and then I can very easily use them here. So this will indicate colon H will have a particular unique identification, colon F will have this particular unique identification. The namespace URI is not used by the parser to look up the information. The purpose of this URI is to give a namespace a unique name. Okay, so the purpose is to give this name. So you can use any other name as well instead of this URL. This URL is not actually looked up or browsed or use any other reference. It's just to identify that this $H has a different value. This $F has colon F has a different value. Okay, so however, companies often use namespace as a pointer to a web page containing namespace information. So most commonly companies tend to use that, but you can use your own names as well. Okay, so a URI, a uniform resource identifier, what do we exactly mean by that? Let's talk more about this. So a uniform resource identifier is a string of characters which identifies an internet resources. The most common URI is the uniform resource locator, or URL, or the browser URL as we call them, or web address, which identifies the internet domain address. Another not so common type of URI is the uniform resource name, URN. This is not so common, but it's also there for special technical people. Most commonly, we prefer this URL. So every time you access www.google.com, you are actually using a URL. It's a specifically uniform resource locator, a name that identifies a particular domain address. So google.com identifies a Google address on its server. W3Schools identifies the name of W3 schools and has an IP address pointing to a particular location on a server. So Defining these default namespaces. So defining a default namespace for an element saves us from using prefix in all child elements. It has the following syntax: XMLNS namespace URI. So this XML carries HTML table information. So if I use table XMLNS and define a particular name URI, this can be any name by that matter, not necessarily a URL. And now I don't need to use this. I don't need to use any prefix because I have used the default namespace. This XML carries information about the piece of furniture. So in this case, XMLNS. So we can now completely avoid the prefix. If we just use the XMLNS is equals to and provide a particular information. Okay. So previously we did use what we call this XMLNS colon H as a prefix. You can avoid it if you just use this as XMLNS in a particular root tag. So we define here as a root. Within this root, now all these elements becomes a part of this XMLNS, this namespace, and no need to provide the prefix. Namespace in real life. Okay, so how do we actually use the namespace in real life? In real use, this XSLT is a language that can be used to transform XML documents into other formats. Okay, so this is the XSLT language. We will be talking in this in advanced XML low course more in this session here. And if you want, you can read more about this here. And if I believe if you go down here, there's more information about this in the SXLT tutorial. If you guys want to have this tutorial more detailed, leave your comment below and I will create tutorials on these parts as well. For now, we are basically concerned with this basics of XML. So it's there. So this XMLNS in real life is basically used to convert your XML document into other formats. How to do that? How does this actually work? Again, as I said in detail, you can go through these tutorials yourself. Or if you want me to make a video tutorial of this, how this is working, leave your comment in and I will try to see how many people are interested and then we can go with that. Okay. So basically, this is talking about that alone. Moving on, next we have finally last major thing within this basic course called display. How the XML documents are actually displayed by the browsers. Let's talk about that. Okay, so a raw XML file can be viewed in all major browsers. Okay, so every major browser is able to display our XML file. Don't expect XML file to be displayed as an HTML web pages. So do be mindful of that. XML web pages are rendered and interpreted and browser reads the tags and displays the information according to the tag. Remember, the purpose of XML is not how the content is displayed, but how the content is saved. So when we view the information, we get this raw XML. So if you look into this, this is an example of how our XML will be rendered on a browser or how it should be rendered. So look at the XML file above in your browser. So if you see this, if you come here, you can click on this node.xml file and here we are. Let me zoom into it a little bit. Where we are, here we are. So if you zoom into it one more time, so you see this. This is an XML file, does not appear to have any style information associated with it. So this is just the basic tree structure. So we see an exact XML document and browser will highlight your tags in a particular color just to give you a good look. And then we get an arrow here on the root tag so that we can minimize or compress and view the whole code. So we get a note to from heading body. This is our basic XML document as we see it. Okay, so you can easily view this thing as we go along. So every time you open an XML file in your browsers, your browser will display this entire content of your XML. It should display the XML file as it is. Okay, if it is an HTML file, then the tags are not rendered. The content is rendered and displayed. Most browser will display XML document with color coded elements. Like I'm using Google Chrome right now, it is displaying me that. Often a plus or a minus sign to the left of element can be clicked to expand or collapse the element structure. So if you see this here, I get this arrow sign, not the plus and minus. In my case, I'm getting this arrow sign to indicate collapse or expand. So if I expand it, I get the whole XML. I can minimize it. To view a raw XML source, try to select try view page source or view source from the browser's menu. So you can view a raw XML as well by going into view source page. So if I come here and maybe go inside the settings, and if you click on view source or go inside the developer tools option, maybe you can view the raw source file as well. So this is our HTML raw content that is displayed, and the sources is basically our node XML content here. We get more information how this XML node XML file is being rendered here. Okay. uh, so since I go back again, to view this XML in other formats, we can go to the source. In Safari and 5 earlier versions, only the element text will be displayed. So do keep this thing in mind. If you're using Mac and if you're using it on Safari, you will not get this output. You will get the actually the text information only. So only the text information will be shown to you. The tags might not be shown in the Safari. So you need to go into view source to see the entire source of it. Viewing an invalid XML file. What happens if there's an issue within a code? So if you open this XML file and we get this error. So this page contains an error in the following line. There is some issue in rendering and we get this message. So if your XML is not properly formatted, there's an issues and you are not following the rules. Sorry, if you're not following the rules that we discussed previously, your browser might give you these errors. So we do be mindful of that. Okay. So we need to be very careful that our XML does follow all the syntax and tree structure rules that we have talked in previous sessions. Other XML examples, you can use other examples. So viewing some XML documents will help you understand how XML is basically working. So there are a few examples here. So I can click on this file and now you can see this. This is a breakfast menu file that we have talked about previously as well. We get a breakfast menu. So there's an arrow we can expand and collapse. We have a food. So all sub elements that have subchilds are again given as an arrows. We can click on these documents and see the whole XML file if you intended. So we have a breakfast. This becomes our root element. Then this becomes another element. Within each element, we have sub elements and so on and so forth. So again, the root element, its sub elements, and the root element, its sub elements, and the root element, its sub elements. Got it? Perfect. If I click on the CD view element, see cataloging, we get another example of how XML documents have been formatted. In this case, we have a catalog as a root element. So if I collapse it, see this is a root element. Each root element now contains CD, and there are tons of data about different CDs within my system. So each CD element now contains sub elements such as title, artist, the country, company, price, year, and so on and so forth. Again, all these tags are my custom tags defined about a particular data set. Okay, plant. Let's see, we view this. So we now have another catalog. This time it's cataloging plants. So we have a plant attribute. Inside the plant elements, we have various different elements of common, botanical, zone, light, blah, blah, blah things. So this is how simply an XML document is structured. Every information that we want to code, we put inside a set of tags. You just have to follow the basic tree structure and the basic syntax rules. Then you give your own names. Works perfect. You have a starting tag, you have an ending tag. What information you put inside the tag depends on you. What is the name of the tag going to be depends on you. What data set you are using depends on you. So why does XML display like this? The XML documents do not carry information about how to display the data. Okay, so these documents do not contain information of how to display this. This is just data. It's just storing data. How to display this, the browser have no information. HTML does. HTML uses H1, paragraph, bold, italic, div. These are all information to the browser telling it how to display the content. XML is just using it to store the data. So since XML tags are invented by the author, they are invented, created, defined, designated, given name by the author. Author give any names. So browsers actually have no clue of what to do with them. They have no idea what to do with them. Only if we are using HTML, they know what to do. But for XML, they have no idea. That's why they render the tags as it is. So we get the whole information as it is. Okay. Without any information about how to display the data, the browsers can just display the XML document as it is. Understand? So this is how we basically use it. This is all about basics of XML. Okay. So we talked about how we display the tags. We open the browsers and browser displays information. So we talk about the namespacing, attributes, elements, syntax, trees, all these basic concepts of XML. If you have followed me up till this point, I hope you understood the basics of HTML. Okay, and this should give us the basic idea of how to use XML. Further on, if you are interested, do leave your comments below, because I want to see if you are interested, then we can talk about more of these advanced topics. The quick tip is that if you want to convert this XML documents into more readable and understandable form, we use this XLT. Like I said, these tutorials are there, especially Ajax, XML DOM models, and XLT tutorials. If you want me to make video on these topics, leave a comment below, and I will see that how many people are actually interested in this and want to learn more about this XML, and we will make more videos on that. Okay, so up till now, if you haven't subscribed, do subscribe. In future, maybe I will be making more tutorials on XML and all these different topics of XML and JavaScript and how we read the data and process the data using XML. So don't forget to subscribe, leave your comments below what you liked and what more you would like to learn regarding this coding, and I will be continuing from this.
Now, XML HTTP request is a built-in object that allows us to request data from the server. By that we mean that using this XML HTTP request object, we can request data and receive the data from the server. It is an absolute dream for web developers. Every web developer loves this and needs to know about this XML HTTP request object. Why is it the dream of every developer, and every developer must be knowing how to use this? Because using XML HTTP request object, you can update the web page, we can request the data from a server, you can receive the data from a server, send the data to a server without actually having the need of reloading the content. So without actually having the need to requesting and reloading the web page, you can request the data from a web server. Okay, so that's the major advantage of using this XML HTTP object. That's why every developers actually love this and needs to know about this. Okay, so if you want to request the data from a server without requiring the reloading option and without needing to reload the web page every time, we need to use this. So what it exactly can do, it can update a web page, it can request data from a server, it can receive the data from a server, at the same time it can send the data to server. So it basically performs all major operations without having the need of reloading the content. So at the back end, your data will automatically be reloaded and going to display to the user without the entire page being reloaded. Okay, so how does this work? Well, it works in a very simple manner. So when you type in a character in an input field, the HTTP request object is sent to the server and some name suggestions are returned from the server. So this is what happens. So if I type something here, for example, hello, okay, what it does is that it will take this data and send to the server, and information is sent back without actually reloading this entire web page. Got it? So how does this actually work? Let's see an example to understand the basic concept. So what we do now is we try to see that first thing you do is you create the new object using XML HTTP request. Okay, and then that object is returned and saved in this particular variable. So once the data is saved inside the variable, now we use this variable to create to access a default function called onReadyStateChange. Now this onStateReadyChange function is executed when there is a change in state, meaning that when there's a response from a server. So whenever we receive a response from a server, or we need to send a response to the server, we execute this onReadyStateChange function inside this XML HTTP object, okay, that we just created. Once this method is executed, we call a function. Again, this is what we call a runtime function, executed at the runtime or created at the runtime. So we say function, bracket start bracket close, since it doesn't have a name, means it's a runtime, one-time execution function only on the time, every time the state is changed. So we say, hey, there's a function, block start, block close. So inside this block clause, we perform two main operations. First, we check whether there was in fact a state change requested by the system, okay, requested by your system or not. So if the request state is 4 and the status is 200, meaning the state was in fact changed, then you need to perform this operation. More about this function we have already talked about in the previous functions. Again, this whole detailed tutorial about XML is in the links description, or you can click on the I icon to find that tutorial. So do watch it to find out more about how XML is working and how it's traversing the elements. Okay, so what we now do is we say, hey, go inside the document, get me an element by this demo name, change its inner HTML to this XML HTTP response text. Now where this response text comes from, it actually comes from this function here. So what we do is we use again this HTTP object. We open a file called file name. You can open a file or you can get a response from a server, depends what it is. The location can change, and we set the status to true, to yes, we want to read the data. So when this status is changed, basically it will call this function here. And then, so again, sorry, when this status is changed, it will call this function here, and this function will actually change the inner HTML based on the content of this file. Once this is done, simple as that. So let's try to see the full example of it. So if you click on try it now, this is the entire HTML for it. Now what's happening is that we create a simple HTML. We have a div tag with an ID called demo. Keep an eye on that because we will use this ID here to change the content. Okay, and we have a button. So basically, again, we don't want to refresh the page. We want to trigger an event that would execute this HTTP request. So we have a button. So as soon as I click on a button, which is on click, it will execute this load XML document. So this load XML document function will be called from here. Okay, so as soon as I click on it, this function will be called. This function will create an object of XML HTTP request, and then after the object has been created, it will check the ready state change. If the state has been changed, it will execute this body, but currently no state has been changed, so it will come here, XML HTTP open get XML info. So it will go and open this state here. Now we get information from our server that will allow us to change the state of the content. So it will say, hey, yes, now we have a request that reads the content area. Oh, sorry, we'll read the content file, and then status is basically changed. Once this is done, then this function on the ready state change gets executed. So now this gets executed. So we have a function block start block close. This will check whether the ready state change is 4 and the status is 200, ensuring that we have a change in function, and then go inside the document, which is this HTML document, and then it will say find an element by ID called demo. This element ID is found, then change its inner HTML. So we need to change the inner content of this demo ID is equals to this dot response. So this basically means this HTTP request object will send a response to us. So instead of this, we can write XHTTP here as well, and we can say response text. So this response text actually is coming from here, the text that we have inside this file. So once we read the file, only then this function will be executed, and then this will change the content here. So if I check it out, we can say, hey, as soon as I click on it, see the content changes without refreshing the page. The content got changed because we clicked on this button here. As soon as we clicked on it, the function got executed, the file was read, and the function on state change method was executed. It has a runtime function called function without any name, block start block close. It ensured, and there's a safety mechanism that yes, the state was changed from the XTTP, and then update the content area, so the content got updated. Okay, so this is how basically very simply an XML HTTP request object works. Very easy, very simple. You can use an on-click event to execute a function that actually changes the state of it. Now, this file can come from a text file, or this response can come from a text file or a server location. Okay, so we can send a server location, server request, and then it will change the server content based on the server request. Okay, so this is what basically this is trying to do. So if you come down, it's giving us a little bit more explanation on this W3Schools website. It says the first line in the example above creates the XML HTTP request object. So this is creating the XML HTTP request object, just like we talked about. Then on the ready state change property specifies a function to be executed every time the status of an XML request object changes. So this function will execute every time the status of this object request changes. This status is changed using the open method. Okay, so we create XML HTTP dot on the ready state change function. Okay, so this property is specified using and then is having a function that is created at runtime. Then as we go along, it checks the ready state properties for, meaning that ensuring that the ready state change is there, and the status is 200, ensuring again the status has also been uploaded. The response is ready. Because the response is ready, now I can change the content of my web HTML. So we say a document, go inside HTML document, find an ID called demo, change its inner HTML, and then the inner HTML is going to be whatever this XML response has been returned from the server. In this case, in this example, we use an simple text file to read it. It can be a server address, which can be based on PHP, and then can request a data from the server, and then you can populate that on your file here. Okay, so this is how simply XML HTTP request object works. Hope it explains many things. So hi guys, welcome to channel Learn with W3Schools. Today we're going to talk about XML Parser. Now, XML parsers are quite essential and important to use when we are working with XML. So all major browsers have a built-in XML parser to access and manipulate the XML. The XML parser is actually the DOM object model, which defines the properties and methods of accessing and editing in XML. However, before an XML document can be accessed, it must be loaded into an XML DOM object. Okay, so all modern browsers have a built-in XML parser that can convert text into an XML DOM object. How does it being used? Let me show you. So what we do is we take this example. Okay, so this example basically takes the string into an XML DOM object and extracts the information from it using the JavaScript. So what it does is we have a standard JavaScript code with an HTML. So we take a IP demo, which becomes an ID. Now we have a script tag. Within the script tag, we define a variable, text, parser, and XML doc. So the text parser contains a special XML document. Okay, that contains a bookstore, a book, title, author, year, book, and bookstore. So this is a standard XML document that we are basically going to use. So the parser is equals to new DOM parser is used using this variable. This method is actually the one that we are going to talk about. This is called XML parser. Okay, this parser function of this parser object will basically be able to parse this XML document. To do that, we use the XML doc, and we're going to use this parse from string text comma text XML. This parser method that we are using from this parser object from parse string is again a default method that exists inside this DOM object. So we create an object, we assign the object to this parser variable. Then use this parser variable and access the parse from string method. We give it this string that we created just right now. So this is passed to this variable here, and we specify the metadata that, hey, this is a text/XML. Then we go into document.getElement by ID. So we say, hey, inside this document, there's an element called demo, which is this one. And we're going to say dot inner HTML, go change its inner HTML is equals to XML doc, which is basically this variable now, get element by its tag name. So this is a default method that we use, and now we have an XML. We access the elements within it, and we say, hey, find out the title with the 0, child node 0, and node. So this is going to access the title with a child node 0 and the value. So the details will be printed here. So this is how basically we parse the content. Again, the key main thing to understand here is that first we use the object, then we use the parse string method. Third, we use this string to read the data from this string method. Okay, so we create an object, we use this parse from string method from this object. We give it the string that we want to parse, which is this one. Then we use XML doc, get element by tag name, title 0, child name 0, value. So 0 is basically index that will point to the first index element that we have available here. Okay, so this is at a 0 index. So it's going to say, hey, find me the title at a 0 index, find its child nodes, and then dot node value. So the node value will be everyday Italian. This is going to get printed. So this is what we use for our standard things. So explaining it, this is our text string. Okay, so this becomes our standard text string that we're going to use. Then XML doc parser is created. In this case, parser is equals to new DOM parser. We create the object. The second step, the third step is using the parse from string method to parse each string. So this becomes important thing. Once we have a string, which is a simple XML document, this can be loaded by default or using any other server-side language that can return the XML document. We create an object, we use this method to process this particular string here. Once this is done, then we use XML and we use the standard JavaScript to parse this content. Okay, now let's talk more about this XML HTTP request object, which has a built-in parser method. Now, this XML dot object has a built-in parser method. The response text property returns the response as a string, and the response XML returns the response as an XML object. So this method has a built-in parser that returns response text and the response XML. So if you want to use response as an XML DOM object, you can use the response XML property, which is this one. How we access it? So for example, if I have this code here, and if I view this code, now in this is a standard HTML. We have a button. So when I click on the button, it will go and fetch the content. How do we fetch the content? So we create a paragraph tag where we want to display the content in our page. We use onClick method load XML document. This is a JavaScript function, so which we create here. So when I click on this button here, this function will execute, which will basically call this method here, which is under the script tag function load XML document. So this is standard JavaScript function, nothing too big about it. Once we are here, then we create XML HTTP on the ready state. First we create XML HTTP is equals to new HTTP request object. Okay. This HTTP request object, like I've mentioned in the previous lecture, as I said, I've already uploaded, I've talked about this, how we access it. So we create a request object, we create an on the ready state change, so that if we receive a response from the server, this method will be executed, and then we call the server and ask for some response. So XML HTTP.open, meaning we are asking the server to send us the data. In this case, we are reading an XML document. Then we send the data. So once we receive a response from here, which becomes true, then this method will be called function, meaning the state has changed. It will check the state. If the state is 4 and 200, meaning that we have received the response, then it's going to call this my function. So this my function again is this function here. So we declare another function that is going to be actually doing the text processing for us. In this case, we have a couple of variables, XML document.xml the response. So we create the XML response here. So we use the default XML object that's here that has been returned to us using this content. So we say XML.response, give it to this XML variable. The text variable is none. Again, the same thing, get element by ID artist. So we get an element by ID artist which exists in this XML document. We process and read the child nodes using a loop. So all our child nodes can be read. And then we're going to print this text on our console. Okay. So if I execute this code, now you see that all the artist lists are printed within our code. So what this is again typically doing is it's reading an XML document using HTTP request that is in cd catalog.xml. It's reading this XML document. Once the document status is true, it's calling a function. This function then uses XML response object with the HTTP request to read the content, and then using this XML doc we get element called artist, and then we loop through this element of artist to print each element, which is again X becomes the XML document X, go through its each child node at the 0 index and print the node value with the BR tag so that everything is printed on a new line. Simple as that. So this is how we get to print and use our XML parser. Okay, so if you have any further questions or if you would like more explanation on this or a few more examples how we use XML parser and XML parser with HTTP request object, do leave a comment below so I can make more appropriate videos or more detailed videos for you to understand. Okay, XML DOM is a document object model, and let's discuss very quickly what it is and how we use it. Let's begin with XML DOM. So what is DOM? Well, DOM is basically a document object model. It defines a standard for accessing and manipulating documents. According to W3 Consortium, which we call the W3C, document object model is a platform and a language neutral interface that allows programs and scripts to dynamically access and update the content, structure, and a style of a document. Okay, so the HTML DOM defines a standard way of accessing and manipulating HTML documents. It presents an HTML document as a tree structure, meaning that using this HTML DOM, every component within our HTML is considered as an object and we can access it and use it like an object. So using, for example, a content inside the body, it behaves like an object, and when we have an object, using an object, we can access the methods and properties of an object. So it becomes much easier to manipulate and work with that particular component when you consider this as an object. And when we talk about HTML DOM, it means that all the components inside the HTML considered as a DOM. Even the browser window becomes a part of a DOM model. The XML DOM specifically defines a standard way of accessing and manipulating XML documents. It presents an XML document as a tree structure. So when you talk about XML DOM, it differs from HTML because now XML document specifically talks about the XML document, and it allows us to access and manipulate all the tags inside an XML document as a tree structure using a simple object-based structure. Okay, so it differs from HTML because HTML DOM considers its tags as an object and it uses that. However, in XML, it considers its tags as a tree structure and allows us to access and manipulate those tags. How we use them, let's talk about. So a standard DOM must so a standard DOM is a must for anyone working with an HTML or XML. So you must need to understand how this is working and how we basically use it. Now, the HTML DOM, all HTML elements can be accessed through the HTML DOM. Keep that in mind. All HTML elements can be accessed through the HTML DOM. This example, for example, changes the value of an HTML element with an ID demo. So if you use this or if you have used any JavaScript before, basically this is exactly what we do. We can create an HTML, give it an ID called demo. This means that now this HTML tag has an ID that is called demo. Then we create a button. Okay, and then on that button we provide on click, and basically we need to use a JavaScript code, which is this one. Okay, so using JavaScript we can access the HTML component. So this JavaScript says that, hey, this is a document. Now this actually document is an object. So this document is considered as an object of our HTML. This document contains access to all HTML tags. In other words, it refers to the entire HTML document or tags that we have created. So it's saying that, hey, I have a document which is an HTML document. Inside this HTML, go get me an element by ID. So there is an element called h1. Find me that element that has an ID called demo. So this will go and refer to this particular component. Then dot inner HTML means that the inner HTML, this inside HTML of this content. So basically we are saying inside the document, there's an element called demo. The inner element of that HTML of that element, get that element, and now using equals to, we can change it to hello world. So when I click on this button, it will change the content here. As simple as that. Then if you go into XML document, the XML DOM basically allows us to access the elements of an XML. So if you have a standard XML like this one, where we create an XML standard metadata, a bookstore, ending a bookstore tag, then we have a book 1 and we have a book 2. So this is a 2 books available. Inside each book, we have a category attribute to the book. Then we have title, author, year, and price. If you want to learn more about the HTML document and how this is created, one of the learn basics, again, I've already created a detailed video on that. The link is in the description. Do check that out. It will explain how the HTML is working. So the code that retrieves the text value of the first title element in an XML document is known as this one. So for example, we create a variable called text, and then we use XML document dot get element by tag name. Now see, previously in HTML we use something called get element by ID. So in HTML we had a get element by ID, this one, whereas in XML we have something called get element by tag name. Okay, so this one is basically what we are referring. Then we say get me the tag called title. Okay, so it finds this title tag here, this one here. Okay, so this title tag will be found. Now this 0 represents the 0 index. So find me a title that is on 0 index, which basically starts from this one. So this 0 index title will be actually referred here. So the next will be referred as 1. Okay, so as an standard array, every element inside our XML also is represented with index numbers. So for example, it's a repetitive. So book, these are 2 categories of XML. This will be on 0 index. This will be on 1 index. So here we are referring to 0 index elements dot child node on 0 index. So again, the child node of that title, if there is any, go for that. Dot node value means inside this node, the value will be every Italian. So this will be the node value that we are actually referring to. So it's saying that, hey, I have an XML document, which is this one. Instead of document, we are now using XML doc, get element by tag name. So instead of using get element by ID, we are now using something called get element by tag name. We are referring to the tag name itself rather than creating an ID. So it's almost same as the HTML DOM, just a little bit differ with respect to these index numbers. So here we are referring to 0 as an index number, and we're saying this 0 on this 0 index, find a child node with, again, on the 0 index dot node value. So find the node value. In HTML we use dot inner HTML. Here we are referring to its value. So this is how basically we access the elements within our XML. So the XML DOM is a standard for how to get, change, add, and delete the XML elements. Okay, so this example loads a text string into an XML DOM object and extracts the info from it with JavaScript. How do we do that? Let's explore the code to understand it in much more detail. So now you can see we have a standard HTML, and we create an HTML tag with an ID called demo. Then create a JavaScript code. We say variable parser and XML doc. So this XML doc automatically has the XML variable information when we provide it here. And then we say text. So we create an XML document text here. Now we say DOM parser. So we create an object of DOM parser. Okay, so this DOM parser will allow us to understand how this DOM parser is working. If you want to learn more about this DOM parser, you can come here to my previous lecture. I just uploaded last lecture that's talking more about this DOM parser class. So you can find out. The link is again in the description. I've already uploaded that. The last lecture before this would be on DOM parser. So I've talked about a little bit that this allows us to parse the DOM, parse the XML documents. Okay, so once you understand that, okay, this is parsing my document. So in order to parse this XML code, we use something called DOM parser. Then we use this parser variable that we just got from here. So this variable is using, and then we're using a method called parse from string text in an XML format. So we're saying, hey, parse in form of a string this variable here. So this is going to read and convert this entire into a parser form of string. Okay, in other words, a string form, so that it can easily be parsed. Then we pass that entire information back to this XML document object. Okay, so now we're going to say, hey, document.getElementByID demo inner HTML. Now go inside this XML document, get me an element tag by tag that is in title form with on a zero index node, find its zero index child node, and then find its value. So it's going to change this value here on this demo node. Okay, so this is again a simple text. Basically, we can say this is initially a text. So we are converting a text into XML using this function here. Okay, so this text is basically being converted into a XML form. This text is because this is a standard text created in JavaScript. JavaScript will consider this as a standard script, standard text to tell our XML that, hey, this is a XML document or XML tags, not just an ordinary text. We need to parse this into an XML form. So that's why we have created a DOM parser. We have used parse from string, means this is a string, parse it and convert it into what we call an XML document. Then we use this XML variable here to find a tag that we want to read based on the index we have, and then we retrieve its node value. So it's going to print everyday Italian, which is this everyday Italian variable node here. Okay, so this is how basically it simply tends to work. Okay, so I hope you understand now what XML DOM actually is and how we use XML DOM. It's quite easy, quite simple. We use the DOM parser to convert our string into a text form, and then we use this get element by ID, or in other words, use this XML doc object to pass through each tag within our XML, and then retrieve its data and process it. And similarly, we can change it, update it, modify it. Okay, so now, XPath is a major element in an XSLT standard. XSLT is actually used to convert our XML document into an HTML and so on and so forth, and basically able to display it. Except XPath is a major element, as I said, in the XLT standard. XPath can be used to navigate through elements and attributes in an XML document. The primary reason is that it allows us to navigate through elements and attributes. So using this, we can navigate and check all the XML document attributes and its tags. So that's why it's quite important. Okay, so if you look into this figure, this defines that if you are using various different things like XQuery, XPointer, XLINK, XALT, they are all combined with something called XPath. So XPath is actually at the center of all these four different technologies and terms we're going to use. And if you want to learn about all these four, as I said, I will be making more videos. Some of them already recorded on my members only page, so don't forget to follow along and become a member so you can get early access to my lectures. Okay, now let's talk more about XPath. Okay, so as XPath is a syntax for defining parts of an XML document. Okay, meaning that it is a syntax for defining specific parts of an XML document. This path uses expressions to navigate in an XML document. As compared to other parsers, this uses expressions. We're going to talk about it a little bit later on. So XPath contains a library for standard functions. It also is type of a library. It's considered as a library, but it actually contains certain standard functions that we use that allow us to do all these operations. XPath is a major element in XLT and XQuery. Okay, so XPath is a W3 consortium recommended. So it's a recommended if you want to become a proper web developer. You know, the W3 consortium or World Wide Web Consortium highly recommends that you follow the XPath so that you can define parts of XML document according to W3 standard. Okay, and use various different functions to traverse and navigate the XML document that have been provided through this XPath. That's why it's at the center point of an entire XML hierarchy. Now, let's talk more about what the XPath expressions are. XPath uses path expressions to select nodes or node sets in an XML document. Okay, so do keep a mind on this select nodes or what we call node sets in an XML document. These path expressions look very much like expressions you see when you work with a traditional computer file system. So an XPath expression can be used in JavaScript. It can be used in Java. That's more important. For me, we're going to talk a little bit about Java in future lessons. So probably we'll use XML using Java, and then we need to use this XPath for that. Anyway, so it uses an XML schema, PHP, Python, C, C++, and lots of other languages. So this XPath expressions can be used in all of these languages. That's why it's so important. That's why it's been recommended by the W3 consortium that you must follow this to define your XML document properly, so that that XML document can later on be used by all of these languages. Okay, so the XPath is used in XLT as well. XPath is a major element in XLT standard. With XPath knowledge, you will be able to take great advantage of XSL. Okay, now let's see an example of XPath and see how it is used. So XPath is used in XSLT. XPath is a major element in XSLT standard. With XPath knowledge, you will be able to take a great advantage of this XL. Okay, so if you want to learn more about XLT, you must understand how XPath is working. So let's see an example of it to get a better overview of how we do. So for example, we use the following XML document. So we have a standard XML document. We define a bookstore, and then it contains book 1, book 2, book 3, book 4, with each book having an attribute category, book category, and book category with certain div tags inside it. Almost all tags have a standard hierarchy. Okay. So this becomes the typical XML document. In the table above, we have listed some XPath expressions and the results of these expressions. So based on this table, based on this XML document, there's a table being given below. Sorry, my bad. Table below, and there are expressions here. Remember, we said that XML is basically based on expressions. So XPath uses expressions to select nodes or node sets in XML document. Okay, so these are some of the expressions that are available which we can use based on this XML document. So the first expression being is \book \book1. Okay, seems very simple. So this basically means that, hey, I have a book which is this one, and I want to access it. So in other words, which belongs to this bookstore tag. So we have a main bookstore tag. Inside a bookstore, we have a book. So the expression we wrote is that, hey, \bookstore, which becomes the main root node, as we call it, then /book, and then index number. This selects the first book element that is the child of a bookstore element. Okay, so this becomes our standard expression. We wrote the root node \book1. So this means that, hey, I have a main root node called bookstore. Inside this bookstore, I have a book, I have a book, I have a book, I have a book. Each book, as per XPath, is on a specific index number. Okay, so we don't know how many books there are. There can be 5, there can be 10, there can be 20. All right, so we start with a 1. So this book or the first entry is actually on the first index. Okay, so here we say, hey, because I want to access the first book, so we use 1 here. So this selects the first element that is the child of the bookstore. Then we can use bookstore last method. So now here notice that we are using another expression here called last. Instead of providing it an index number, we are providing it a last function. Okay, so we're using the round brackets. So now we are saying, hey, select the last book element that is the child of a bookstore element. So selecting the first element will basically allow me to select by just typing 1. It will allow me to select the first element. By selecting using the last function, we can select the last function. Similarly, I can say go to the bookstore, again the root node, go inside a book, and then use last -1. Selects the last one, but one book element that is the child of a bookstore element. Okay, so it's going to select the last -1, means second last elements. Then we can use bookstore book position function less than 3. Now this becomes more interesting. So now we are using one more function called position. Selects the first 2 books elements that are children of the bookstore elements. Okay, so now what we're doing is I just need to select the 2 books, for example, or top 5 books, or the top 5 entries. In fact, these are not marked with respect to category. We are saying, hey, I just need the top 2 books in my entry. So the entry of top 2 books is important. So what I do is, in this case, 1, 2, 3, 4. We have 4 books available, right? So I just want to fetch the first 2 books. So these first 2 books basically I want to fetch. So in order to fetch these 2 books, again, this is on index 1, this is on index 2, this is on index number 3. So we remember that. Okay, so now what we're going to do is we're going to come here and we're going to use another function called position, and with a relational operator called less than 3. This means find me the books that are less than 3 index. So it will find the book on index number 1. Okay, it will find me book number on index number 2. Because it's less than, it means that less than 3. So 3 is actually an exclusive number. It will always remain 1. Hence, it will return the first 2 books. So we will get book 1 and book 2. The first 2 books are returned to me. So in this case, the first 2 books are our cooking category book and our children category book. These 2 first books will be returned to us. Got it? So similarly, there are various different expressions that we can write. So now we have something called double backslash. So here now we are using double backslash and we are saying title @ language. So what this basically means is that, hey, /title at the length. So it selects all the title elements that have the attribute name language. So if you note, I have various different subtags, right? So we have title, we have title, we have title, we have title. So all these books have title inside it, and they have an attribute called lang. Okay, so then since we have this attribute called lang here, we have a lang English and we have a language English. So now means that first we need title and we can have a lang attribute. So we are saying to this guy, okay, I need to find all the books that have language set as English. So we can have language set to any other variable as well. So now we're saying, hey, find me all the books, find me all the books that have this lang element. So it selects the title element that have an attribute named lang. You can specify that find me all the books that have title at the rate lang, means we need this attribute language is equals to English. So now it will find me all the books that have as an English value. Okay, so if you come back here, you would notice that we have language as an English, we have language as an English, we have language as an English. So now, okay, wonderful, we understand that. So if you want to find a specific book that is in French or in German, for example, and you're using that variable, you can easily use this expression here to access those elements. Okay, wonderful. So this is how basically we progress. Now we can further even go, hey, go inside the root book, find me a book that has a price greater than 3,500. Okay, so note how we are writing the expressions. We can customize and write any expressions that we want based on the content and the tags we have in our HTML. In this case, we are saying go inside the book root. There's a books inside this my XML. Find me the book that's price is greater than 3,500. So in this case, now if you go here, if we have a book, each book has something called a price. So each book has something called a price here. Each book has something called a price here. But I want only those books whose are greater than 3,500. Only those books whose price is greater than 3,500. I don't want to see all of these books. So in this case, we wrote a condition here. So this is basically another expression that says that find me book, square brackets, and within the square brackets, we wrote greater than sign 35. So find me all the books that have a greater than 35 value. Similarly, we can even further add more things to it. So we say, hey, go inside the book store, find a book whose price is greater than 35 / title. So select all the title elements. So this basically means that I actually want the title of all the books inside the bookstore that have price higher than 35. So give me title. Okay, so this will be returned. So the output will be basically your title. So give me title of all those books whose price is greater than 35. Simple. So see, now becomes even more complex expressions. So this is what an XPath does. It allows us to traverse and process the HTML things. Anyway, so in previous sessions, if you've been following along, we did talk about this XPath, Parser, and HTTPRequest, and I already have a detailed video covering all these XML concepts. So with XSLT, you can transform an XML document into HTML. That's the key thing and the wonderful thing about this thing. XSLT allows us to convert our XML document into HTML. That's the major beauty of this thing. Okay, so this extensible style sheet language transformation, it stands for XSLT. It's a tongue twister, really. So this XSLT is basically an extensible style sheet language transformation, is a recommended style sheet language for XML. So it works like an CSS for HTML, right? So if you can consider that, so it's for XML. So using this, you can convert your XML document into what we call HTML web page. Wonderful, right? Very easy, very simple. So how do we do that? XSLT is more sophisticated than CSS though. See, so it is more complex, more sophisticated. With this XSLT, you can add or remove elements, attributes, or from output file. Okay, so meaning that with CSS, it's only used for primarily what we call design purpose. So it cannot actually add, delete HTML content. For CSS, it needs HTML content and you can just work on that. We call it that it's more sophisticated because with this, it has this add or remove concept as well. So using XML, you can create an HTML page using XSLT, and this allows us to also add and remove components as well. Okay, you can also rearrange and sort elements, perform tests, and make decisions about which element to hide and display and lot more. So there's many things that goes inside it. XSLT uses XPath to find information in an XML document. So it's quite important and essential that you understand what XPath is, because this XSLT will use XPath to find information. We have talked briefly about XPath already in my previous video, and we're going to talk a little bit more in depth. A whole full course of XPath is about to be released, hopefully by next month. And if you want early access, again, do check out the membership page. You can find the video already there. Now, let's try to do this example of XSLT. So we will use the following XML document. Again, a standard XML document we have, in which we have a root menu called breakfast menu. We have an element called food, and it contains various different sub elements. Again, food, food, food. So we have a breakfast menu, and it contains various different XML elements. Now, the task is to convert this into what we call an HTML. To do that, we use XLT to transform the XML into HTML before it is displayed to the browser. So before it's sent to the browser, actually we need to convert it into HTML. Otherwise, it's going to just render the same XML file. So to ensure that it displayed as an XML into an HTML, we need to convert it using this XLT style sheet. Now, do note that just like CSS, this is also referred to as sometimes a XML style sheet, or generally XML CSS as well in the general terms as we call it. But again, this is XLT, a form of style sheet for XML. Now, what we do in this one is, again, we have a standard XML, and we wrote the HTML XSL version 1.0 XMLNS XL metadata. So we transform. So we provide the metadata within the HTML tag, letting it know that which XSL version we are using. Again, extend this XSL, and then so we define body. Again, now here is our standard CSS. So this is a standard CSS code. Okay, so for XSL, we for each select breakfast menu food. So now here the XSL code starts. This is saying that if I just delete this so that I can rewrite it. So here is our extended XSL code. What this is doing is that it says for each select breakfast menu food item. Now, within the first line, we are telling that I am using the XSL colon. For each is the loop that we use. Again, in XML, we have just the structure, but using XSL, because it's more powerful, it's able to transverse and transform various different elements within XML. So we are using loops to do that. So we are using loops to traverse each element. That way, with a small piece of code, we can completely traverse a very long XML document as well. So this for each is a loop that will traverse through each element. Okay, so we say select breakfast menu food. What does the breakfast menu is? So if you check the breakfast menu inside this, you will find that we have food, but before the food we have the root element called breakfast menu. So this breakfast menu root element has been specified. Inside the rest we have a food element. So idea is, go inside the breakfast menu. Inside this you will find an element called food. Inside food there are various different tags. Okay, but first we need to access the root, then the main tags that are basically repeating, which is the food, 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 food item. So here's exactly what we're doing. We say, hey, inside, go use the XSL, use the for each loop that exists inside this body. Select is equals to select, again, is an attribute that we use with this XSL, and we specify that there is a breakfast root menu, inside it there's a food menu. Now, once you read this element, what do I need to do? So we use a div, again, now HTML, style background and background color, the color for the font color, and the padding white. Now this is again pure CSS. So we are again using the HTML tag. So this becomes our HTML. This is again inline CSS we use. Okay, so this is again CSS. This is HTML, and this is what we call XSLT. Okay, so see this, how multiple language frameworks are combined together to create an output. That's the beauty of this XML. Okay, you want to learn more about HTML, my video is already on the channel. You can find all about HTML and as well as CSS. My detailed courses are on this channel, find that out. Okay, so span, style, font weight, bold, blah 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 things. This is again whole HTML code. This is again where the XSLT starts. So how the mixture is there, how we combine HTML with XML XSL is a wonderful feature that you need to follow. So now here what we're saying is that in XSL colon value of, now value of is again another function that is used to traverse the elements inside our food. So we say select name, and then we XSL value of select price and div close. So now we're going to print all these things together. So we're going to say div paragraph, XSL value of description, span, and then again use whatever way you want to present it. Again, XSL value of select calories. So now here are four main things that are basically being used. Each food item has value of name, one thing, then it has a value of price, second thing, then it has a value of description, third thing, then it's a value of calories. Okay, so this four thing, all these four are actually child of what we call this thing. So if you note here, okay, every breakfast menu has a food item inside it. Okay, inside the food items you would find name, we have a price, we have a description, and we have something called calories. So these four subtags are there. Now using XSL we can access these four items in our code using this XSL value of function. So XSL value of select is equals to calories, XSL value of select name, XSL value of select description, and XSL value of select price. But this basically is using for each loop to traverse all the food items. So what's happening now is again that we are going into food item and then we are using these names here, description, description, and calories. So we are traversing these names inside the food item. So this can have 5 foods, this can have 5,000 foods. The code will be basically the same and we can traverse it. To view the output, see, this is the beautiful output that we get. So now the XML document is quite simple, quite straightforward, but traversing it using XPath and XSLT logic, we basically are able to convert this entire document into a wonderful output. And this again depends on the CSS, how you want to define it, how you want to use it. So it's actually all up to you how you're going to process it. So this is how our XSLT works in a simple sense. So let's talk about XQuery. So let's begin. Now, what is XQuery? XQuery is to XML what XQL is to database, meaning that in terms of database, we need SQL language to query database and retrieve data from the database using this SQL language. Similarly, XQuery was designed to query XML data. Okay, so it's a kind of a query language, it's kind of a query concept that allows us to retrieve specific XML data in a query form. How does it work? So for example, we use a for $x in document books.xml. So now this is a loop for, we use a for loop and we say, hey, I want to loop through various different elements in my doc.books.xml. So using loop, we can traverse complete XML with a very short piece of code. And we're going to say, hey, inside this books.xml, we have a root node called bookstore. Inside it, we have an element called books. So we want to read all the elements that are of type books inside this root element called bookstore. This entire XML actually is inside this XML file. So using this loop, we can traverse through the entire XML. So we now use conditions or whatever operations we want underneath this for loop. So we can say for where $x, this $x is price is greater than 30. So this means that find me an element or sub element inside the book where the price is actually greater than 30. So I don't want to retrieve all the elements in this example. I'm just saying that, hey, I need the elements whose price is above 30. So when you find that element, save that element inside $x variable. So then we can use order by. Now, if you have done SQL, you would know that order by is used to sort the data in a particular sequence. You want to learn more about SQL specifically, the tutorial is already uploaded on my channel. You can find it in the links in description. That is talks about complete SQL in about 1 or 2 hours, right? So find that and learn more about SQL. But coming back to here, order by is used to sort the data. So this will basically sort the data based on the title. Okay, so it uses title as to sorting mechanism, and then it says return $x title. So once you are done with this all sorting, return me this title. So it's a form of query that we write to loop through each element inside an XML file, and we provide certain conditions with where clause, and we use certain other conditions to sort the data and then finally return the data. So together they basically form a complete one single query. Okay, so this is what basically XQuery does. This is what basically XQuery allows us to have. What exactly is XQuery? XQuery is a language for querying XML data. That's the key thing here. So instead of just reading the entire content, we use specific query concept to retrieve specific queries. Okay, and then we can perform operations on it just like we perform certain operations on database. The XQuery for XML is like SQL for database. XQuery is built on XPath expressions. So if you have already listened to my previous lecture, it's already uploaded on this system, XPath. So find out about that. You want to learn more about XPath in detail, again, my detailed video lecture is also going to be uploaded, so don't forget to subscribe. So XQuery is supported by all major databases. Wonderful thing. So that means no matter which database you're using, XQuery can easily be supported and used for other databases as well. It is a W3 consortium's recommended. So W3 consortium recommends that when you're talking about XML, you must understand and use this XQuery path as well. So these are some basic features that we need to learn and understand about this XQuery as well. So XQuery is about querying XML language. So XQuery is a language for finding, extracting elements and attributes from an XML. So it extracts the elements and various attributes from an XML documents. Here's an example. So for example, if you write a standard query, we write select all CD records with a price less than $10 from a CD collection stored in a catalog. So this is what basically the entire query represents. It's different from reading data just like we did in previous things like XML Parser. It parses all the elements, or we read a specific tags. This time we are writing a specific query, which means that it has a specific conditions and circumstances, and it can be used for particular data analysis, that we want to use this data and we want to find out what's happening there. So it says find out all CD records with the price less than 10. So this becomes one condition here, and this condition will return us this CD records from the CD collection. Okay, so this CD collection becomes what we call our root. Okay, this becomes our root, which entire thing is stored inside this XML file. Okay, now this XML file can be a static file, just like in previous example, or we can say this can be returned from our server. So using this again is not a specific query, this is just a general normal written form, and we can write this in a query form. XQuery and XPath. So XQuery 1.0 and XPath 2.0 share the same data model and support the same functions and operations. If you have already studied the XPath, you will have no problem understanding XQuery. So don't forget to watch the XPath tutorial as well, because I've already uploaded it. It's on my channel. You can find it, again, the links in the description. This will allow you to understand how the XPath is working. If you understand it, basically XQuery follows the same standard. XQuery examples of use. So how do we, or where do we exactly can use this? So XQuery can be used to generate information to use web services. Okay, so it's typically used to generate information to use in web services. So all major web services basically use XQuery to get information and extract information from the XML file. It is used to generate summary reports. So we can very easily generate summary reports from our XML document, just like we can from databases. So if you are using MySQL, you use SQL queries to generate reports, get feedback, what is happening in the database, get a summarized value. If you're using same thing with Oracle or any other database, we use SQL to return us the reports. We use SQL to generate us reports. The same thing you can do with XQuery using XML. So it transforms our XML data into XHTML data. The value that's returned to us is in form of XHTML. So search web documents for relevant information as well. So you can use XQuery to search web documents for relevant information. So you can understand it's quite important in terms of working with online data, digital data, specifically if you're not working with database. If you're working with XML and other form of relevant information, XQuery is quite essential. So XQuery is a W3 standard consortium recommended, which is World Wide Web Consortium. So World Wide Web Consortium is recommending it that, hey, you must use this for XML, and you can use it for compatibility with namespaces, XLT, XPath, and XML schemas. Okay, so we're going to talk about these things as well in my coming lectures. Some we have already done. Again, much detailed lectures are to be followed. Okay, so this is a brief intro of what XQuery is and how you can do it. Today, we're going to talk more about XML, XLINK, and XPointer. So let's begin now. XML, within XML, we have something called XLINK. XLINK is used to create hyperlinks in HTML, in XML document. So just like in HTML, we have what we call an anchor tag. This allows us to create links inside the HTML. Similarly, in XML, we use something called XLinks to create hyperlinks. Make sense? Okay, so if you want to learn more about HTML, again, my detailed tutorial is in the description. You can check it out. I have made a complete 4 hours videos on how to use HTML. But HTML uses this anchor tag to link between page 1 and page 2. So we use this link tag to do that. Similarly, we use XLink to link between tags. Okay, so this tag can be linked to another tag. Okay, to do that, we use something called XLINK. Now this XLINK can be linking page on one file, and this can be a completely different XML file. So this is a different XML file, this can be a completely different XML file. Both can work. Means that you refer to tags, or you can link tags within the same page or within two different XML files, similar to anchor tag. So anchor tag also can do the linking between the pages and or between multiple websites, between multiple pages, and within the same page as well. Same goes with the XLINK as well. Again, the difference is we use with a tag with HTML. With XML, to create these hyperlinks, we use something called XLINK. Make sense? Okay. So now within this XML, we have already discussed what we call XQuery. We have talked about XSLT briefly. We have talked about XPath as well. So today, basically, these two things will be discussed. So this will complete the entire circle of our XML concepts. So XLINK is used to create hyperlinks within XML. Any element in an XML document can behave as a link. So that's the key thing here. You can convert any element that you write inside your XML and convert it into what we call a hyperlink. So with XML link, the links can be defined outside the linked files as well. So again, saying the same thing. So this can be a link, okay, and then there can be another link as well. But this can be a completely separate file .xml, and this can be a completely separate file. So you can link XML tags between two different files as well as within the same file. So this is what it's trying to say. So you can have this thing here, and you can link, click on one tag, and it will point to another tag or another element in another file. XLINK is a W3 consortium's recommended as well, just like all of these things as well. So it is part of W3 consortiums. Do keep in mind that XLINK browser support is critical. There is no browser support for XLINK in XML documents. That's a big bummer that we need to face, but we have to be careful with it. However, our major browsers do support what we call XLINK and SVG. So we have to be careful where you want to use it. Okay. So moving on further, now let's just talk more about XLINK syntax itself. So in HTML, the A tag is used to define hyperlink. However, this does not work in XML, because obviously XML is completely different. So in XML document, you can use whatever element name you want. Therefore, it is impossible to browse, and this is impossible for browsers to predict that what link elements will be called XML documents. So that's why the support is quite low within the browser. So the browsers, it's very difficult for them to exactly know what's happening. But within the XML, you can convert the links. So to do that, below is an example of how we use XLINK to create our documents. So for example, we create an XML document with the standard root metadata. Then we create a home page. Okay, so this becomes a home pages. Here we define XMLNS :XLINK. So now this is again XML namespacing :XLINK. So we use the XLINK and is equals to, we provide the link here. Okay, so we need to define the namespace first. Now namespace means to avoid the naming conflicts. We have talked about namespace already here in the previous videos in a complete 1.5 hour tutorial where I talked about all these concepts in one video. So don't forget to check that out so you can understand what exactly we mean by namespaces. So this is a simple namespace XLINK path here. Then within the each element, we use XLINK type, simple XLINK href, and we provide the reference link just like we do in href with the anchor tag, and then we provide the text here. So the idea is that when I click on this text, it will take me to this link here. Make sense? Similarly, we can say homepage XLINK type simple is just going to be simple link XLINK href. So this is the hyper reference that we are creating here. In anchor tag, if I'm doing HTML, we use href in a simple sense. So we use just like this. Okay, and then we close the tag, and then we can say click here, and this becomes here. So when I click on this text, it takes me to this using the A tag in HTML. However, in XML, we use something called XLINK :href, and we provide the link. And then again, same, we provide the text here. So when I click on this text, it is going to jump to this point. So this is how we create a very simple our XML links. To get access to an XLINK feature, we must declare an XLINK namespace. So this is the namespace that we use here. Again, namespace to avoid conflicts and issues. So XLINK namespace is, in this case, this one here. So this is the namespace that we are going to use. So the XLINK type and the XLINK reference are attributes. There in a home page element comes with an XLINK namespace. So the XLINK type simple creates a simple HTML-like link, means click here to go there, right? So this becomes a simple HTML type. There's no fancy thing here. So it defines that, hey, I'm just creating a simple link. So the HLink href attribute specifies the URL. So in this case, this is what basically the breakdown is. Okay. Now let's link the example. So let's use one more example of it, how it works. So the following XML document contains XLINK features. How it's working? Well, the link is quite simple. So what we're doing now is, again, we create an XML document. We define a root element book space. We define the XML XLINK namespace. So this is a namespace that we need to provide, which is referring to this XLINK namespace website. So it's taking the namespace from this URL. Okay. Then we have a book tag, and then we have a book tag. Now both these book tags have something called a title Harry Potter. This is a title XQuery Kickstart. Then we use something called descriptions. Now this is where we can provide the link here. Okay, so in this description we use XLINK type simple, href to the website. So when I click on the content, it goes here. Show new will basically take me to the new page, new tab in other words. And we have a content here. So this means that we have a description that is of XLINK having type, href and show. This will create the link for us. Okay, so this is actually the link tag in a very simple manner. Same, you provide XLINK type simple, XLINK type href. Now see this. This is a different URL, different URL, everything else same. So it's quite easy to understand, quite simple. As long as you define the namespace, then you can define the links individually within each tag. Okay, so if you explain this code, or if you need more explanation, here it what says. It says that the XLINK namespace is declared at the top of the document. So we need to declare the namespace first. This becomes the first requirement. Then we use type simple that will allow us to create the simple HTML tag. Then we say XLINK href. This becomes the third point. We provide the hyperlink, and then we use the show link that specifies the link should be open in a new window. Simple. So you use these 4 attributes to create links. So wherever you need to create a link where the content needs to point to some other resource, whether it's a GIF image, whether it's an HTML file, whether it's a URL, or whether it's another XML file, this is how it basically works. Going further, in the example above, we have demonstrated simple links. Our XLINK is getting more interesting when accessing remote locations as a resources, instead of just standalone pages. So if we start the value of the XLINK show attribute to embed, the link resources should be processed in line within the page. So when you consider this could be another XML document, you could, for example, build a hierarchy of XML documents. So you can specify when the resources should appear with an XLINK acute attribute. How this attribute works, let me just say. So for example, here we have used certain other attributes as well. So you can use XLINK acute as well. On the queue, you can say value can be on load, on request, other, or none. So this defines when the link resources is read and shown. So on load, the resources should be loaded when the shown and the document loads. On the request, the resources is not read or shown before the link is clicked. Similarly, instead of acute, you can also use href, like show attribute, like type attribute. We already talked about that. Href needs to have a URL. Show will usually, we have used the new means we want to use a window, or you can just embed it within the same window. Okay, you can replace the current entire content, or other or none can go for it. Type, basically we use the simple, which basically specifies the type of link we are creating. We can use extend, locator, arc, resources, title, none. Usually just simple would work fine for us. Okay, so this is what it actually means. Using the acute, you can specify when the resources should appear. So this will allow us to control when the resources should appear. This show will mean that it will show the resources in a new window. Href link is there. So you can exactly control this with acute as well. Now, the point is that this will point to new files or new resources or new locations. But what if I want to refer to the same tag within the same document? To do that, we use something called X pointers. Okay, X pointers again are part of XML, and they are very specific to XLINK and XQuery. X point allows the links to point to a specific part of an XML document. X pointer uses XPath expression, so that's why we say it uses the XPath expression to navigate in the XML document. So we have already talked about XPath in this previous video. Again, the links in the description. You can listen to more about it. So X pointer browser support. So there is again no support for X pointer as well, just like other things. So we have to be careful where we use it and what exactly we're expecting. So X pointer example. Now let's explore the example. X pointer, the idea is that we provide a one tag here, and then within the same document we have another tag here. So when I click on this tag, it points to this tag here. This is what X pointer allows us to do. So within the same XML document, we use tags to navigate between and within the documents. Okay, between the elements within each document. That's the X pointer's whole purpose is. To do that, we use something called pointer, which basically points to this location here. Okay, so we need that pointer thing. So that pointer thing is actually this ID attribute here. So in this example, we will use X pointer in conjunction with XLINK to specify a part of another document. We will start by looking at the target XML document as well. Note that this can also point to the same document as well as another document as well. So it's not necessary that the X pointer only works within the same document. Okay, you can use this to point to another XML file as well on a specific tag. So to do that, we use a key thing called ID. Okay, so this ID is actually the main thing that we use. How we use it? So for example, we have XML document, we create the root element, so this becomes our root tag. Then we define the element tags dog. This time what we have done is we have defined dog, given an attribute called breed, but this attribute is the key thing, ID. Same goes for the next ID. Notice that everything can be different because every tag has its own elements. However, the ID again has to be also different. ID basically meaning that now we are giving an ID to this tag, we are giving specific ID to this tag. Using this ID tag, we will pinpoint to this location or this specific tag. Okay, so in note that XML document above uses ID attributes. Yes, we said that. So instead of linking the entire document with XLINK, pointer allows you to specify parts of the document. So instead of linking the entire document just like we did here, where we link to the entire website, web pages, or entire XML files or GIF files, this will actually link to the entire files. It will open the entire file. But this X pointer allows us to point to a specific location, specific tag within the same document or within the two external documents. How do we do that? Again, so once you specify the ID attribute, okay, once the ID attribute is specified, this ID attribute now can be used to refer to that particular location. So following that, we create another XML file, define the XML, we define our standard root tag, my dogs. Again, note that uses the namespacing XLINK. So it uses the XLINK. My dog description, again, the tag element is here. This time, wherever we want to create the link, we use, for example, a fact tag, XLINK type simple. Same thing with that we just discussed with the XLINK, XLINK H reference. However, note the reference this time. The reference uses the file name hashtag Rottweiler. This Rottweiler is used with the hashtag. Now this is key thing. So we use a standard URL .xml file hash Rottweiler. So now this means that I'm specifically pointing to the Rottweiler tag in my content here. So this will come here and point exactly to this point here. Okay, because we are using the same ID here. We are using the same ID. So when you do that, it's going to come here and point that. Same case here as well. So if you note, we have something called voila, this thing, hashtag. So this hashtag allows us to identify where we want to point in a particular place in the document. This hashtag is known as pointer. Okay, in general HTML, we simply call it ID. Okay, but ID is used with ID attribute. So we use ID is equals to inverted quotations. Hash is specifically not used with the ID name. In XML, hash is used there. But we can use hash in HTML, but it just means they're referring to the same page. Here, we are referring to hash, indicating that, hey, I want to point to this particular location. That's it. So that's all you need to do. You need to come here and understand that if I need to point to a particular tag, I need to provide an ID without the hash in this case. Okay, so we provide an ID without the hash case. Now I want to point to this location. I come back here, I use the URL. Now this can be my same URL. If I'm using it within the same document, I don't need to use this whole URL. I can just write hash Rottweiler. This would mean I'm pointing to the same document. As simple as that. If this is supposed to be another document, so when I click on this link, it's going to exactly jump and show me this particular tag here. So when I click on it, this tag is going to be displayed. Okay, so if I come back here and if I click on the Rottweiler concept, if I click on here, because it's referring to this URL with a hash, it's going to jump to me and show me this content here. Sure, makes sense. Okay, so XLINK is actually creating links within our HTML document. Within the same document, you want to display the whole page, you want to point to a specific pointer location, you basically can do that using XLINK things.